Thank you. A very special thanks to Srimati Bornali Das for that beautiful invocation. Now may I request our dignitaries to kindly take their seats on the dais. May I call on stage Professor Ramesh Chandradeka, Professor Somak Raychaudhary, Dr. Kumar Mishra, Shri Mrinal Kumar Hazarika, and Professor Dr. Ashoka Goswami. Can we have a big round of applause for our guests? We are indeed honored to have our esteemed guests with us in today's program. Before we proceed further, we would like to felicitate them. I would request Ms. Onimita Goswami, daughter of late Professor Dr. Anil Kumar Goswami, and Disha Sharma to do the honors. It is our privilege to felicitate the Vice Chancellor of Cotton University and today's chief guest, Professor Ramesh Chandradeka. The Vice Chancellor of Ashoka University and today's invited speaker, Professor Somak Raychaudhary. The President of the Assam Science Society, Dr. Kumar Mishra. The Secretary of the Assam Science Society, Shri Mrinal Kumar Hazarika. Now invited speaker, Professor Somak Raychaudhary. The Assam Science Society would like to present a bundle of books to our invited speaker, Professor Somak Raychaudhary. I request the President of Assam Science Society, Dr. Kumar Mishra, to do the honors. May I request our team to felicitate wife of late Professor Anil Kumar Goswami, Professor Dr. Ashoka Goswami. We would also like to felicitate the Secretary of Assam Science Society, Shri Mrinal Kumar Hazarika. Thank you so much. We have amidst us the younger brother of late Dr. Anil Kumar Goswami, Dr. Dibakar Goswami. I request him to deliver the welcome address.
Namaskar, Swagatam. আজি আমি সমবেত হৈছোঁ প্ৰয়াত ডক্টৰ অনিল কুমাৰ গোস্বামীৰ স্মৃতি চাৰণ সভাৰ উদ্দেশ্যে। আজিৰ সভাত মঞ্চত উপবিষ্ট বিশিষ্ট ব্যক্তিসকল শ্ৰী ৰমেশ চন্দ্ৰ ডেকা, উপাচাৰ্য কটন বিশ্ববিদ্যালয়, প্ৰফেসৰ সোমাক ৰায়, Raychaudhary খ্যাতনামা প্ৰফেসৰ পদাৰ্থ বিজ্ঞান, বিশিষ্ট বৈজ্ঞানিক তথা ভাৰতৰ হাৰিয়ানা প্ৰদেশৰ অশোক বিশ্ববিদ্যালয়ৰ উপাচাৰ্য। ইয়াৰ উপৰিও বিজ্ঞানৰ বিভিন্ন ক্ষেত্ৰত তেখেতৰ অৱদান উল্লেখনীয়। এই মঞ্চত আছে আমাৰ মাজত ডক্টৰ অৰূপ কুমাৰ মিশ্ৰ, সভাপতি আসাম বিজ্ঞান সমিতি, শ্ৰী মৃণাল হাজৰিকা, সম্পাদক অসম বিজ্ঞান সমিতি, ডক্টৰ অলকা গোস্বামী, ইয়াৰ উপৰিও আমাৰ অসম বিজ্ঞান সমিতিৰ কৰ্মকৰ্তাসকল, অসমৰ বিভিন্ন প্ৰান্তৰ পৰা অহা অসম বিজ্ঞান সমিতিৰ সভ্যসকল, পৰম শ্ৰদ্ধাৰে আমন্ত্ৰিত সুধীবৃন্দ, পৰিয়ালৰ ব্যক্তি ও বন্ধু বান্ধৱসকল, মৰমৰে আদৰণীয় ছাত্ৰ ছাত্ৰীসকল আৰু সন্মানীয় আদৰণীয় প্ৰেছ মিডিয়াৰ কাৰ্যকৰ্তাসকল, আজি বিশেষ সন্মানেৰে এই সভাৰ কাৰণে বিভিন্ন স্তৰত কাম কৰা সকলোজনলৈ আন্তৰিক সন্মান জনালোঁ। মই দিবাকৰ গোস্বামী, প্ৰয়াত অনিল কুমাৰ গোস্বামীৰ কনিষ্ঠ ভাতৃ। মই নিজেও পৰিয়ালবৰ্গৰ সকলোৰে হৈ আপোনালোক সকলক সন্মানেৰে এই সভালৈ আমন্ত্ৰণ জনালোঁ। ধন্যবাদ।
Thank you, Dr. Goswami. Now, on behalf of the family members, daughter of late Dr. Anil Kumar Goswami, Srimati Anita Goswami will deliver the welcome address.
Respected Chief Guest, Professor Ramesh Chandra Deka, Vice Chancellor of Cotton University, invited speaker Professor Somak Raychaudhary, a physicist of international repute and Vice Chancellor of Ashoka University, President of Assam Science Society, Dr. Kumar Mishra, Secretary of Assam Science Society, Shri Mrinal Kumar Hazarika, and Professor Dr. Alaka Goswami, representing our entire family, esteemed faculty members, distinguished guests, all members of press and media, members of the extended family, students and dear friends. Last but not the least, all life members of Assam Science Society who have assembled from all over the state. It is my profound honor and privilege to welcome you all to this special occasion, the first Dr. Anil Kumar Goswami Memorial Lecture. Today we gather not only to celebrate academic excellence, but also to remember and pay tribute to a remarkable scholar, an inspiring teacher, and a visionary leader. Dr. Anil Kumar Goswami, former principal of Cotton College, now Cotton University, spent his entire life teaching research and upgrading this institution to a center of excellence. He dedicated his life to popularization of science amongst youth in particular. His contributions to the field of physics, his unwavering commitment to education, and his deep love for Cotton College have left a legacy that continues to guide and inspire. It is a matter of great pride for us to have with us today our invited speaker, Professor Somak Raychaudhary, eminent physicist and Vice Chancellor of Ashoka University, Haryana, a distinguished personality whose work and leadership have made profound contributions to the scientific community. Sir, we are deeply grateful for your presence and for taking the time to join us on this meaningful occasion. Your insights and words today will truly enrich this gathering. The family of Dr. Anil Goswami, in association with Assam Science Society, has taken the first step today to hold this commemorative lecture. We aspire to have many more such events to celebrate the life and work of Professor Anil Goswami. So, without much ado, I once again welcome the dignitaries seated on the dais and the attendees of the August gathering. Your presence adds value to this event and honors the memory of Dr. Goswami. As we begin today's program, let us carry forward the spirit of curiosity, dedication, and humility that Dr. Goswami embodied. May future generations be inspired to carry on the ideals cherished by this stellar human being. Once again, I extend a warm welcome to each of you for your presence. Thank you and have a pleasant day ahead.
Thank you, Srimati Anil Goswami. May I now request the President of Assam Science Society, Dr. Kumar Mishra, to enrich us with the life, work, and legacy of late Dr. Anil Goswami.
Namaskar. Very good afternoon to all the dignitaries on the dais, of the dais, and dear students of historic Cotton University. Already, his younger brother and daughter have formally offered the welcome address, where they spoke bits and pieces about the life and times of Professor Anil Goswami. The responsibility of introducing him, as a matter of fact, with two relations. One, the organizer of this event, Assam Science Society, and the chair I hold now. And second, the most important one, being a part of the family. Professor Goswami was my mother's Khuda. I should have called him Kaka, which I never did, because when I met him, he was very young, active, agile. So deliberately I called him Khuda only, following my mother and uncles. He always, in various meetings all over the state, he used to mention that and he jokingly used to mention that very few occasions are there, meetings are there, of state and national level, where grandfather and grandson are sharing the dais. These are the things which I remember every day since he has left us. Very difficult to, capture his life in a short way, but I'll try to do it. In the book also, you will get the reprint of the article I wrote in Assam Tribune when he had passed away on the day of the Shraddha. It is the wish of Professor Ashoka Goswami. Before the Shraddha itself, she had told me that we need to do something. And immediately the thing came to mind was an annual memorial lecture, coupled with a few other things which still has to be decided, like offering fellowship, scholarship in his name. A book has been very carefully taken care of by Pankaj Hazarika, and he has done a lot of work to bring out that book, which we will get today. Who was Dr. Kumar Goswami? A professor, a dreamer, a friend of the students, social reformer, institution builder. What was he? For many, he will have different names or memories to share with. He was born in the historic Khotiamari Khatra near Vijayanagar, Kamrup, to Bhubaneswar Goswami and Jageshwari Devi. He had a checkered academic career, schooling in various places. Barbata, Kamalpur, Guwahati. Finally, he came to the Cotton College Higher Secondary School, from where he secured the 4th rank in matriculation from Guwahati University at that time. Seba was not born in 1949. Brilliant student, he received the Auniati Khatra Gold Medal for Assamese essay writing in the whole state. In 1951, he again secured the 6th rank in ISC, examination of Guwahati University, sealing the ultimate stamp that getting 4th rank in metric was not a fluke. I deserve it. I have it. He secured first position in MSc from Calcutta University with specialization in nuclear physics and cosmic radiation in 1955. Then came back to Assam. Probably for a few months he was working in some school, but then Cotton College invited him as a faculty, and he joined here teaching for some time. In 1967, he obtained his PhD in microwave relaxation in ferrites from University of Sheffield, UK. This is the phase where we saw him as basically a scholar, an academician, a student always able to learn something in life. Then the middle phase, I call it the phase of consolidation. Morning shows the day. Already the day is over, and now he's in the consolidation phase. He devoted his life for teaching and research in Cotton College. Also side by side promoting popular science through Assam Science Society. He was one of the students in 1953 when a group of Cotton College professors had started the Assam Science, then called Guwahati Science Society, later on named Assam Science Society, in this particular campus. He saw it in 1953. So he took this platform as a potent weapon to drive home the beauties of science and technology, the small things in life, the nuances of healthy living, peaceful living. He always believed that. In number of occasions he told me, scientific temper নহলে বুঝছো আমার এইবোৰ মারপিট খড়িয়াল দ্বন্দ্ব এইবোৰ শেষ নহয়. He was very upset whenever news used to come about some কুসংস্কার অন্ধবিশ্বাস, ডাইনি হত্যা, etc. He was extremely unhappy. So, in the process, Assam Science Society should not remain only as a state-level program implementer or doing some on and off some awareness campaigns. He thought it should be playing a better role. The way Prayag Sahitya Sammelan, Vigyan Prayag Rajmis Allahabad Science Society, Bangyo Vigyan Parishad, Marathi Vigyan Parishad, they used to play a stellar role in social development. Next phase, we will see him as a person who was trying to advocate for Science Museum Complex, some center under National Council of Science Museum, top level R&D institutions, etc. When I became a student of this college in 1978, in the pre-university science, I always saw him after the class, the laboratory he used to run. খুৰা ক'ত যায় এই বহুত ডাঙৰ কাম আছে ৰ somebody is coming from Delhi I need to meet him এজন মানুহে কেতিয়াও চৰকাৰৰ ঘৰলৈ গৈ পেলাই সায়েন্স সোসাইটিৰ কাৰণে বা বেলেগ ইনষ্টিটিউচন পতাৰ কাৰণে সংকোচ কৰা নাছিলে যিটো বহুত মানুহে মানে ভুল বুজিছিলে সেইজন হ'ল অধ্যাপক অনিল কুমাৰ গোস্বামী আজি গুৱাহাটী উজান বজাৰৰ মাজমজিয়াত কম মাটি আছে হ'লেও গুৱাহাটী প্লেনেটৰিয়াম বৰাগাঁও ISST which has been taken by DST এইটো ৰিজিওনাল সায়েন্স চেণ্টাৰ বা নেশ্যনেল সায়েন্স চেণ্টাৰ খানাপাৰাত ইনষ্টিটিউট অফ ফিজিক্স সোনাপুৰত You tell me where you don't find the footprint of Professor Anil Kumar Goswami. কোনে কি কয় লোকে কি কয় I don't care. মই কৈছিলো আপুনি যদি কনভিন্স হ'ব লাগে এদিন তেওঁৰ কৈ আছে চিফ জাষ্টিস গুৱাহাটী হাইকোৰ্টে দেখাল এলাৰ্জি আৰম্ভ হ'ল ৰাতিপুৱা গৈ ঘৰৰ বাৰান্দাত বহি থাকো তেওঁ কয় you have come again sorry can't part this small piece of land গণেশ মন্দিৰৰ মাটি কিনি যদি প্লেনেটৰিয়াম এখিনি হাইকোৰ্টৰ বাটি নিদিও I cannot give you গৈ এনেকুৱা পৰিৱেশ সৃষ্টি কৰিছে বাধ্য হৈ কৈছে you want it we'll give it আজি বিজ্ঞান ভৱন Assam Science Environment Councilor Office Remote Sensing Office মই ডাইৰেক্টৰ আছিলোঁ জয়দীপ বহি আছে ডাইৰেক্টৰ সেই কথা কোনে আনিছে অনিল কুমাৰ গোস্বামী এজন মানুহে দিছপুৰত লাগি প্ৰাইম ল্যান্ড জিএছৰ ওপৰত আছে আজি বিজ্ঞান ভৱন 5 মহলীয়া বিল্ডিং থিয় হৈ আছে সগৌৰৱে কোনে আনিছে অনিল কুমাৰ গোস্বামী লগত আছে না চিন্তা কৰে যদি কোনোবা যায় ঠিক যাম আদাৰৱাইজ গো দেয়াৰ he'll go to দিছপুৰ CMৰ পৰা মিনিষ্টাৰ এমএলএ লবি কৰিব IST লবি কৰিব ক'ব we want this এজন মানুহ পালো যোনে কেতিয়াও নিজৰ কাৰণে এক ইঞ্চি মাটি এটা টকাও নিবিচাৰিলে কিন্তু সমাজৰ কাৰণে কাম কৰি গ'ল এজন অনিল কুমাৰ গোস্বামী He was General Secretary of our society. Aji ami not as the chairman of pollution board. I am here as president of society. 75 বছৰ General Secretary. Again 95 to 97, 99 he was the president. আৰু সেই সময়তে অসম বিজ্ঞান কমিটিয়ে নতুন ধৰণৰ যাত্ৰা আৰম্ভ কৰিছিলে আজিও মনত আছে আমি যে প্ৰিলিমিনাৰী সেকেন্ড ইয়াৰ পাইছো মোক ৰাস্তাত লগ পাইছে তই ডিস্ট্ৰিক্ট লাইব্ৰেৰীলৈ আবেলি সময়ত আহিবি কি আছে দেখিবি কি আছে গৈ দেখিলো থাৰ্ড নোবেল লৰেট ওমেন নোবেল লৰেট কিনে তাত লেকচাৰ দিব আহিছে একেলগে ISSTও মুকলি কৰিছে আধাৰশিলা আৰু লগতে তেওঁ লেকচাৰ দিছে So some of us were very lucky. মোৰ লগত ল'ৰা আছিল আমি বল গোস্বামী মাতিছে যাওঁ তাৰ আগতে আমি নোবেল লৰেট দেখা নাছিলো তেনেকুৱা আছিল মানুহজন ৰাস্তাই ঘাটে লগ পালে বেছি সময় নাই চিঞৰ কৰি যাব কিন্তু তেওঁ আমাৰ নিচিনা হাজাৰ ল'ৰা-ছোৱালীৰ মাৰ্গখন কৰিছিল আজি গোটেই অসমত গোটেই ভাৰতত পৃথিৱীত হাজাৰ মানুহে তেখেতক পেলাই as an institution builder and very soft sympathetic teacher 91 পৰা 96 লৈ তেখেতে Aztecৰ director হিচাপে কাম কৰিছিল he worked as director of Aztec in all sectors of contemporary science আজি হয়তো আমাৰ we have got AI machine learning AR VR so many things নাছিল 91 তেতিয়া ডাঙৰ বস্তু আছিল work for renewable আৰম্ভ হৈছে ভাৰতৰ যাত্ৰা পুনৰ নৱীকৰণ শক্তি আৰম্ভ হৈছিল যাত্ৰা এনভাইৰনমেন্টৰ কাৰণে আৰম্ভ হৈছিল যাত্ৰা সায়েন্স টেকনলজি পপুলাৰাইজ কৰাৰ কাৰণে ৰিমোট সেন্সিং আহিছে ভাৰতত ইণ্ডিয়া ইজ অলসো ফোৰ্স এট দ্যাট টাইম এই 5টা বছৰ তেওঁ সেই চাৰিটা ডিভিজন চলাই পেলাই অতি সুন্দৰকৈ তাতে নেতৃত্ব দিছিলে কাম কৰিছিলে আৰু তেতিয়াই মই ইঞ্জিনিয়াৰিংৰ পৰা কেমিকেল ইঞ্জিনিয়াৰিংৰ লেকচাৰ হিচাপে আহি পেলাই তাত জড়িত হৈছিলো My life as a science communicator or popular science worker started under his guidance from 1993 আজি আৰু এজন মানুহ এটা বহি আছে ডক্টৰ অশ্বিনী কুমাৰ বৰুৱা তেওঁ যেতিয়া এছেন্ট্ৰি হেড আছিলে সেই মানুহজনকো ইঞ্জিনিয়াৰিং কলেজৰ আমাৰ ডিপাৰ্টমেণ্টৰ পৰা লৈ আহিছিল কুমাৰ গোস্বামী he was number 1 best in finding out potential from various places কোন কলেজত কোন স্কুলত ভাল মানুহ আছে, কাম কৰা মানুহ আছে, তেওঁ বিচাৰি পেলাই উলিয়াই লৈ জানিছিলে। After serving as professor at head of the Department of Physics in Cotton College, he became the principal of this college. His biggest achievement, if you ask me, as principal was to invite Honorable President of India, Dr. Shankar Dayal Sharma, to this college. Tekheter mukhe declare koraisil Cotton College as Center of Excellence and Postgraduate Studies. On 17 October 1992, মোৰ খুব ভালদৰে মনত আছে, President of India stepped into Cotton College and graced the occasion. আৰু সেইদিনাখন তেখেতৰ যিটো মুখৰ এটা হাঁহি, এটা আমি জীৱনত পাহৰিব নোৱাৰোঁ কেতিয়াও। তেওঁৰ যিটো সন্তুষ্টি আমি জীৱনত পাহৰিব নোৱাৰোঁ। It was Professor Goswami who was instrumental in the establishment of Center for Radio Astronomy and Inspiration Development Center, and also Faraday Bicentenary Park in Cotton College. As a recognition to this, in 1996, he was elected Fellow of the Royal Astronomical Society. He was member of the steering group of SCT Sector in Planning Commission, He was chairman of NCSC network, G2 Bharatborshot, Prihot NGO Homoheta Club, conglomeration of various NGOs, voluntary bodies in India. That Amio Silahon Kam Kurisilu, Tao 2007 পৰা 9 লৈকে তাৰ chairman আছিলে। He founded Pragjyotis Amateur Astronomy Association, led it since 1999 till his last breath. Tao kuno keতিয়াও change নকৰিলে। He was always the president of this organization. He was a man for all seasons. Aji kam hal hobo, kali kam beya hobo. নহয় জিতাম কাম উল্লেখ কৰে। সকলোৱে মনত আছে তেওঁৰ এটা চিৰপৰিচিত এটা ৰূপ, এটা পৰ্টফলিঅ' বেগ, এখন কাগজ লৈ পেলাই হাতৰ তলত এনেকৈ লৈ পেলাই আহে। আমি যিটো সময়ত চিন্তা কৰোঁ ৰ'দ বেছি, বৰষুণ দিব পাৰে, কি কৰিম, গাড়ী চাড়ী এখন পালে যদি যাব পাৰোঁ যাম কামত, তেতিয়াও দেখা পাওঁ মই পানী টেংকিৰ ওচৰত পাণবজাৰত বা শিলপুখুৰীত তেখেতে চিঠি বছৰে ৰৈ আছে। ক'ত যায় আপুনি? বোলে কাম এটা আছে, বতৰ বেয়া হৈছে, একো নহয়, ছাতিটো আছে ভিতৰত, মই দিছোঁ, আজি যাবই লাগিব, আজি নকৰিলে কামটো নহ'ব। That was his karmaspriha. He had firm belief, আগতে কৈছোঁ, that science and technology can transform societies, build nations, propel economics to new heights. Scientific temper in society can stop wars, bring peace and prosperity, and foster natural integration. তেওঁ যে কিমান অনুষ্ঠানৰ লগত জড়িত আছিলে মই কৈ শেষ কৰিব নোৱাৰোঁ। তথাপিও কৈছোঁ, ডক্টৰ বি বৰুৱা কেঞ্চাৰ ইনষ্টিটিউট, আছাম ডাউন ইউনিভাৰ্চিটি, লায়ন্স ক্লাবৰ বিভিন্ন অনুষ্ঠান, ৰোটাৰী ক্লাব এজ এ মেম্বাৰ, দুটাক মানে হ'ল ৰুৰেল টেকনলজি একশ্যন গ্ৰুপ। এসময়ত ভাৰতৰ প্ৰধানমন্ত্ৰীৰ চাইণ্টিফিক এডভাইজাৰ ডক্টৰ চিদাম্বৰমে আৰম্ভ কৰিছিলে ৰুৰেল টেকনলজি একশ্যন গ্ৰুপ দুটাক। এতিয়াও ভাৰতত মাত্ৰ 6খন নে 7খন আইডিয়া আছে, কিন্তু গুৱাহাটী আইডিয়া নাছিলে। আৰু গুৱাহাটী আইডিয়াত যিমান ডিৰেক্টৰ ৰেজিষ্ট্ৰাৰ আহে সকলোৱে ওপেন হেণ্ডছ উইথ ফোল্ডেড হেণ্ডছ কয়, ছাৰ আপুনি আমাক ৰেডি দিব, প্লিজ কাম এণ্ড ৱৰ্ক ফৰ আছ। তেওঁ বহুত কাম কৰিছে ৰুটাকৰ জৰিয়তে, বহুত কাম কৰিছে, যিবোৰ আজি মোক ক'বলৈ সময় নাই। When I was in Vigyan Prasad in Delhi as a senior fellow, he was also a member of the governing body of Vigyan Prasad, the DST body. Eastern Center for Radio Astrophysics, WWF of India, the board of আছে, যিটো জানে worldwide fund for nature, তাত কি ধৰণে প্ৰফেসৰ গোস্বামী কন্ট্ৰিবিউট কৰিছিল। In 2019, he was awarded DSc honoris causa by Assam Down University, and in 2022, he was felicitated as an outstanding scientist by B. Burua Cancer Institute. I am no one to judge him as a professor, as a scientist, as a researcher, but definitely I can tell you one thing. He was a human being par excellence. He was a human being par excellence. তেওঁৰ পৰা শিকিবলগীয়া বহুত আছিল আমাৰ, বহুত আছিলে। বহুতে তেওঁক দেখা নাপালে, বহুত দেখা পালে, শেষৰ পৰা তেখেতে ঘৰত বন্দী হৈ আছিলে। তেতিয়াও আমি গ'লে সদায় সায়েন্স টেকনলজি কেনেকৈ আৰু আগুৱাই লৈ যাব পাৰি এজ এ ছ'চিয়েল ৱেপন, সেই কথাখিনি কৈছিলে। চ' মই হয়তো বহুত কথা মিছ কৰিছোঁ, হয়তো বেলেগ কথা কৈছোঁ, কিন্তু ফৰ মি এজ এ মেম্বাৰ অফ দ্য ফেমিলি, ক্ল'জ ফেমিলি, and also as president of the organizing body today here, it's very, very difficult to say more than this what I have said. এইখিনি কৈ আজি এই পবিত্ৰ দিনত আমি আমাৰ যাত্ৰা আৰম্ভ কৰিলোঁ। আৰু আপোনাক কথা দিছোঁ, অসম বিজ্ঞান সমিতিয়ে সদায় প্ৰতি বছৰে এই অনুষ্ঠানটো কৰি যাব। I don't believe in season flowers. I believe in evergreen trees. যদি আমি থাকো সকলোৱে ঠিকে থাকো তেতিয়াহ'লে আমি এইজন মনীষীৰ নাম আমি জীয়াই ৰাখিম। তেওঁৰ মাধ্যমেৰে আমি আৰু কিছুমান কাম কৰাৰ পৰিকল্পনা আছে। অলপ এখনো গৈছোঁ ঘৰত যাওঁতে 1 ডিচেম্বৰ হৈ যাব দিয়ক, লাহে লাহে প্লেন কৰিম। তেখেতৰ বৰ ইচ্ছা আছিলে ফিজিক্সৰ ল'ৰা ছোৱালীক ৰিচাৰ্চ গ্ৰাণ্ট দিয়া, ফেলোশ্বিপ দিয়া, স্কলাৰশ্বিপ দিয়া। আমি সেইবোৰ লাহে লাহে ঠিক ঠাক কৰিব লাগিব, প্ৰট'কল কি কেনেকৈ কৰা হয়। কিন্তু অসমত যিটো দেখা যায় সাধাৰণতে বহুত খেলৰ টুৰ্ণামেণ্ট আৰম্ভ হয় এজন মানুহৰ নামত, শেষত বন্ধ হৈ যায়। বহুত মেমৰিয়েল আৰম্ভ হয়, প্ৰমিছ বন্ধ হৈ যায়। এইটো নহয়, তাৰ কাৰণে মই মোৰ বিজ্ঞান সমিতিৰ যিমানখিনি আমাৰ পৰা আহিছে আজি, ঠগোখানা ধেমাজিৰ পৰা আৰম্ভ কৰি গোটেই অসমৰ মানুহ আহিছে ইয়ালৈ। এটা মিহলি হৈ বহি আছে বিজ্ঞান সমিতিৰ। মই আপোনালোকক কৈছোঁ যেন মোক সদায় আপোনালোকে মনত পেলাই দিয়ে, আপুনি কণ্ট্ৰলত ডিচেম্বৰত কৈছিলে সদায় প্ৰতিষ্ঠা পাতিম বুলি, আপুনি কি কৰিছে? If I forget, please remind me. ধন্যবাদ, thank you very much.
Thank you, Dr. Mishra, for giving us a glimpse of Dr. Anil Kumar Goswami's legacy, his vision and leadership, his contribution to research and education, and his extraordinary list of achievements. To honor his legacy, a commemorative book has been produced on the solemn occasion of the first Professor Anil Kumar Goswami Memorial Lecture. Titled in Memoriam, Dr. Anil Kumar Goswami is edited by Dipankar Hazarika. Dipankar Hazarika is a well-acclaimed editor of Assam with experience of editing more than 100 valuable publications, which include souvenirs, journals, biographies, compendiums, etc., for various state as well as national organizations, and also for the government of Assam and government of India in the last 3 decades. I request Shri Dipankar Hazarika to join us on the dais, and I also request our dignitaries to kindly come forward and release the book on this solemn occasion. May I request our dignitaries to be kindly seated in the auditorium as we prepare the stage for the invited lecture. Vice Chancellor of Ashoka University, has graced us with his presence as today's invited speaker. I would like to speak a few words about him before we hear his talk. Professor Somak Raychaudhary is the Vice Chancellor of Ashoka University, where he is also a professor of physics. Prior to this, he was the director of the Inter-University Center for Astronomy and Astrophysics, IUCAA, Pune. Dr. Raychaudhary graduated from Presidency College, University of Calcutta, and went on to study physics at Trinity College, University of Oxford, supported by an INLAC's Shivdasani scholarship. He did his PhD in astrophysics at the University of Cambridge, supported by the Isaac Newton Studentship, where he was awarded a JT Knight Prize. He then moved on to the Harvard-Smithsonian Center for Astrophysics, CFA, in the Cambridge, USA, as a Smithsonian Fellow. He stayed on to work in the High Energy Astrophysics Division of the CFA, working for a NASA project as part of the team that built the Chandra X-ray Observatory, now in orbit. At this time, he was always a fellow of Lowell House, Harvard University. Dr. Raychaudhary worked at the IUCAA Pune as an assistant professor for a few years in the 1990s, moving to the University of Birmingham, UK, where he taught at the School of Physics and Astronomy for more than a decade. He moved back to India in 2012 to help rebuild Presidency College, Kolkata into Presidency University, where he was Dean of Science and Professor and Head of Physics till he moved to Pune in September 2015 as the fourth director of IUCAA, which is one of the top research institutions in astrophysics in the world. His work involves a wide range of topics in cosmology and astrophysics and has made seminal discoveries using observations at radio, optical, and X-ray frequencies from the ground and from space. He has worked on exotic stars such as black holes and neutron stars in nearby galaxies, including our own galaxy, the Milky Way. He has worked on observational cosmology in determining the scale and age of the universe. He pioneered the study of galaxy superclusters as the largest structures in the universe and has discovered some of the largest structures of galaxies in the universe, including the Saraswati supercluster of galaxies. In the recent past, he has been in leading positions in several of India's mega science international projects, including the 30-meter telescope and LIGO India. He has developed innovative machine learning algorithms for mining large astronomical data sets and recently co-chaired the committee to compile the vision document for the government of India for the next decade of astronomy research. So can we have a big round of applause for our speaker, Professor Somak Raychaudhary. He will be delivering the first Professor Anil Kumar Goswami Memorial Lecture, and he will be speaking on the future of the universe. So as we prepare the backstage for his talk, once the stage is set, I will invite Professor Raychaudhary to deliver his talk. Thank you. Sure. Vice Chancellor of Ashoka University has graced us with his presence.
Okay, good afternoon. Please take your seats. Thank you. And thank you very much. My voice has a problem today, but thank you very much for coming, all of you. And thanks to the organizers for an amazing introduction to me. I'm really honored to be here for the first lecture in honor of Professor Anil Kumar Goswami. This picture was given to me by my colleague at Ashoka University, Bikram Pukon, who is a member of the family. And I remember first meeting Professor Goswami here in Guwahati in the beginning of 1996, when there was a remarkable meeting held of the Astronomical Society of India. Astronomical Society of India was there in all over India from the 1950s, 1960s. It was established in Hyderabad, and it has at that time held its meeting every 2 years all over India. But it had never come to the east, not even Kolkata, and nowhere in the northeast. And Professor Goswami made an amazing effort to convince everybody to bring the meeting of astronomers to the northeast, to Guwahati. And it was also my first Astronomical Society meeting, because I had just returned from Harvard and had joined Ayuka in Pune a few months before that. And not only did I have the opportunity to come to Guwahati, that was my first time with 700, I think, astronomers, but also I had the fortune to meet Professor Goswami for the first time. And several times after that, as he was building his radio astronomy unit here at Cotton College. Professor Goswami used to come to Pune to work with, to talk to Professor Govind at NCRA, and my friend Raychaudhary, who was later became the first Vice Chancellor of Cotton University, was also there. And several times during that time, I had the great fortune meeting him. So I have very high regards for not just his erudition and scholarship, but what he did for science in this region. And thank you very much for inviting me to invoke him in this wonderful occasion. Thank you, all the family members. What I want to talk to you about is on this occasion, talk to you about what we know of the age of the universe and what is going to happen in the universe as a whole. I am a cosmologist, and I use all different kinds of instruments that is available to me in trying to understand the universe as a whole. That is the job of cosmology. Now, you would want to know how I can even presume to understand the universe as a whole by applying the laws of physics that we get from the laboratory, and that is the magic of it all. The fact that we can learn physics from our classroom, our labs on the small scale, apply the same physics to the universe out there, the whole universe, and even try to understand it. And we can understand a lot of the universe. And over the last few decades, we have tried to understand how the universe has evolved. So, I wanted to ask the question, how do you know how old the Earth is, or the universe is? What did people think? Now people know that the universe is many tens of billions of years old. But if you look at the early calculations in the West, as opposed to in the east, in the west, you can see that even as late as the 17th century, and this is only 300 years ago, people were thinking that the universe and the earth were less than 6,000 years old. Right? The most predominant scholars, prominent scholars of Western philosophy, including Isaac Newton, believe this, that the universe is only a few thousand years old. And people were making predictions down to the date and time of when the universe was created, based on biblical scriptures and interpretations of what is written in the Bible. This was questioned by a remarkable man called Charles Darwin. In the middle of the 19th century, Charles Darwin, and you expect an astronomer to come here and talk about astronomy, but my hero is Charles Darwin. Charles Darwin, in the middle of the 19th century, was proposing his theory of evolution of the human being. And he said, look, if you really want the kind of evolution that I am proposing, we need the earth to be at least 300 million years old. Right? So you're saying 6,000 years old, and Darwin wants it 300 million years old. At that time, the best estimates came from various sources. So we're talking of how the Venerable Bede or even Newton in the 17th century were talking about the universe being 6,000 years old. At the time of Darwin, if you turn to physics, the best estimate was from Lord Kelvin. And Lord Kelvin was talking about maybe 100 million years at the most. You can stretch it a little bit more. And Lord Kelvin was getting this from a very clever argument. Lord Kelvin assumed that the Earth is a fragment of the sun. And what happened is that he assumed that the sun actually had some pieces fall off the sun, and they formed the planets, and they have been cooling. We know that the sun's temperature is 6,000 degrees Kelvin on the surface. So you assume that the Earth is about 6,000 degrees to begin with, and now it is 300 degrees Kelvin. That is. So how long does it take rock to cool? From 6,000 to 300. And he was making experiments to see how fast rock cools. And based on that, he said, I can give you about 100 million years. And Darwin was saying, if you have to get all these species around you, you can't get that happen in this amount of time. The people who came to Darwin's rescue were not physicists. They were the geologists. The geologists in England worked out that in order to get the rocks formed the way they are, sedimentary rocks, you really need up to a billion years at least in order to find the rocks that you could get. And so they came to the rescue of Darwin, whereas the physicists were completely against this idea. Right? And so there was considerable argument going on at the beginning of the 20th century, about 100 years ago only, when radioactivity was found. And then of course we know how carbon dating is done and things like that. All that came much later. Carbon, radioactive carbon dating is 100 years old. People don't understand that. People think that we've always known that the Earth is so old. We now know that the Earth is 4.5 billion years old. And it's the sun. And it so turns out, as you will see, that we now know that the universe is twice that age. So we now know that the sun and the Earth were formed about halfway in the age of the universe. And the star that we call the sun is actually quite a young star. And it is not the first generation of stars. It is a generation of stars that is 10th, 11th, 12th generation of stars. The earlier stars formed much earlier. all that we have known only in the last 50 years, within the lifetime of most people in this audience. Right. And that is one of the stories I'm going to tell you today. So what I want to tell you also is from my perspective as an astronomer, this is what I'm interested in. I look up at the sky and I see stars. You have a small telescope, you can see stars like this. But, and then you think, and this is what human beings have thought ever since the telescope was invented, that's all there is in the sky. People were thinking, what are these stars? We don't know. It's like things up in the sky, maybe they're all at the same distance. And a lot of people did not know how far away these stars are. The crux of an astronomer's problem is to find out how far away stars are. We did not know how to measure distances to stars till the 20th century, about 100 years ago. Right? And so we did not know whether these stars are all there is in the universe. Even in the 1920s, a famous debate is taking place in Washington, D.C. between some of the top astronomers in the world meeting together where people are debating whether the universe is made up of stars. And the stars that you see in the sky is all there is, and that's the end of the universe. And there are some people who are saying, no, the stars that we are seeing actually belong to our own system, and there are many islands in the universe. In these islands there are stars, and we are seeing only our own stars. Right? This is the... Now, if you contrast this with the deepest picture we know of the universe now, and this is the one that is taken from the James Webb Space Telescope last year, called the Deep Field. You will see that all the things that you see in this, taken by one of the best telescopes in the world, there is only one star. And that's the one that has this asterisk on it. Every single other thing in that picture is actually a galaxy. And each galaxy has 100 billion stars. This we did not know 100 years ago. When Einstein asking is that there are two kinds of stars that you can see. Some seem to be fuzzy, they don't twinkle. And there are some that twinkle. Another person that you see on the right, somebody called Charles Messier, who was in France, who was asking the same question at the same time for a different reason, and that is because his king had asked him to find out which things in the sky are comets and which things are not. And he was trying to figure out whether these fuzzy things in the sky are comets or not. And he made a whole list of stars that don't twinkle, but they are not comets. Anybody who's an amateur astronomer amongst you uses the Messier list all the time with the telescope nowadays. So this started this whole argument of people finding out why are there two kinds of stars in the sky, some that look fuzzy and some look point-like that twinkle. And I've given you 4 examples of these nebulous stars, fuzzy stars in the sky on the picture here. And the pictures I've given you are modern pictures taken by modern telescopes. But 200 years ago, they all looked the same in the sky. And you will now understand what the major problem of an astronomer is. A major problem for an astronomer is to find out how far away things are, because only then you know how big things are. The sun and the moon, if you look on the sky, are the same size. But actually, they're not the same size. It's only when you know how far away, that one is 1,000 times further than the other, that you know that one is much bigger than the other, right? Similarly, these things that you see, you will see the top one, actually, the top thing that you see, a globular cluster, has 1 million stars. It's a cluster with 1 million stars. But on the sky, with not a very powerful telescope, it looks like a single star that's a little fuzzy. Whereas on the left, in the bottom, you see the Crab Nebula, which is the remnant of a star that exploded 1,000 years ago. That's what it looks like now. It's one star. And in the middle, you see M51, the Whirlpool galaxy, which has 1 billion stars, which is one of these galaxies, right? Also looks the same. And this confused people for a very long time. And this was all resolved in the 1930s, less than 100 years ago, when people started measuring the distances to things. That was a big revolution in astronomy when we started measuring distances to galaxies. And I'll tell you, towards the end of today's story, in the 1990s, we had a second revolution when we figured out how to measure distances to galaxies, and that taught us a lot about what the universe is made of. So we now know that the universe is made up of galaxies, and they look like this. Many galaxies are nice and round. They're called elliptical galaxies. Other galaxies are flat and rotating very fast, and they are called spiral galaxies. So if you haven't thought of this ever before, this is the galaxy that we live in now. We live in this galaxy. We call it the Milky Way. And it looks like this. It is actually a flat thing. It's like a chapati with the center bulging up a little. And our sun is not even at the center. It's a little further away from the center, right? And it is about 20,000 light years away from the center. And what we see in the sky, you see, we live in that small little layer of stars. And our Earth is going around the sun. And so what we are seeing in the sky, when we look up at the sky, are only stars that live in this part, this little thin layer. Okay? And outside that, there's nothing. But if we could look towards the middle of the galaxy, then you would see a whole band of stars, right? Much, much denser there. The problem is, from the northern hemisphere, you don't see much of the center of our galaxy. The Earth blocks it. If you go to the southern hemisphere, this is what you look at. 2 weeks ago, I was in South Africa. I was looking up at the sky, and this is what I was seeing. This is a picture from Chile, and you can see you can see what that is. This is a real picture, by the way. This is not a real picture. This is an artist's impression, because you really can't take a picture like this from inside. But this is a real picture, and you can see from inside, if you look towards the middle of our galaxy, you would see this band, and that is why it's called Akash Ganga. It's like a river of stars in the sky, right? And And that's what you see, and you see the middle of the galaxy is there where there's a black hole. And this is taken from an observatory in northern Chile, where I've gone many, many times and observed all these things. There are also two other galaxies that you see with the naked eye from the southern hemisphere. They call the Magellanic Clouds. They are our moon galaxies. They go around our own galaxy. So we have big galaxies, and then you have tiny galaxies that go around the big galaxies, right? So that's how we know what this is like. And this is something that we've started to understand, as I said, in the last 80, 90 years. So this is now you can figure out, then you can look around, and then you can ask where in the sky are galaxies that look like our galaxy. And you can see something like this. This is an actual picture of a galaxy that looks like our galaxy. And you can figure out what our galaxy looks like by looking at an external one. And if you start turning it around, you will see how it starts looking like what we see in our galaxy. So if you turn it around, you will see that you get a side view, and you can feel that it's flat. And then you can see that if you have galaxies like ours nearby, which are absolutely edge-on, you can see them as flat. And you can take that, and you can see that's exactly what you see. This is a real picture of our own galaxy. We are inside, and we are looking at towards our own galaxy, towards the middle, and you see that in the sky and the Milky Way. You can see parts of it from here as well, if you know where to look, and you have to go very far away from the city, and you will see parts of the Milky Way, but not really at the center as it is. Okay, so now we know we live in a galaxy, and the universe is made up of galaxies. How are these galaxies distributed in the universe? Galaxies don't like to live on their own. They live in small groups. Our galaxy lives in a very small group. We are very unimaginative in naming things. We call it the local group. And it has got two big galaxies, the Milky Way and the Andromeda galaxy. They're falling towards each other, right? And in about 4.5 billion years or so, they're going to merge and become one galaxy. Now, each of these galaxies have little tiny things that are going around them, the satellite galaxies, the dwarf galaxies. And we know of about 30 to 40 of such small galaxies around our own galaxy that are going around. So now we are beginning to understand the general geography or cosmography around us. It's like very much in the 15th, 16th, 17th century when people were taking ships all around the earth and trying to figure out what the earth looked like, what the continents look like. We are starting to do that now for the universe. And we're trying to figure out where we are and how the matter and light is distributed. And we also know, now we've tried to now measure distances to galaxies in some way and make three-dimensional maps of the universe. So the left-hand side, there is a map that is one part of the sky, and for about 1 million galaxies, we have now made a three-dimensional map. And we can take slices from it and see how things are oriented. And we now can see that galaxies are not distributed in a very uniform way. There are very filamentary structures in there, very much like a spider's web. And we call it the cosmic web. That's how galaxies. And so one of the challenges now in astronomy, and astronomy is a very modern astrophysics, cosmology, very, very new subject. As new as, as I said, but less than 100 years old, where we're trying to understand how the universe the galaxies are distributed in the universe in this fashion, and how did it happen? How did the universe, where did it start, and how has it come to a stage where it looks like this? So how did it start? It started, we think, with something called a Big Bang. A Big Bang was not a bang, that's a cartoon. It just meant that it started off at a time, t equals 0, and there was a lot of energy. And since then, the universe has been expanding, and it has come to a stage where the universe is a pretty big place where there are these hundreds of billions of galaxies and so much space in between. Interest in this particular aspect of the universe was started in the 1980s by Stephen Hawking, who wrote this very popular book, which many of you will possess and would have read, called A Brief History of Time, in which he not only said what I just said now, which is the fact that we now know that the universe started from a time and has been expanding, but he speculated in that book. It's a very interesting book. I was very fortunate that when he was writing the book, he was giving lectures based on the book, and I was then a student in Cambridge attending his lectures. So even before this book was published, I had the privilege of actually attending some of the lectures that led up to this book. And I could see how this was all coming together very interestingly. So what he was saying was that let us think about what will happen to the universe in the future. And this is why I've called my talk to the future of the universe. He said if the universe really started from a point and has been expanding, and I'll tell you in a moment how we know that, then if there is a lot of matter in the universe, and you know matter has force of gravitation, it is going to pull back the universe. And after a point, the universe will slow down, and if there's enough matter, it will stop, and then it will come back again. Or, if there's not enough matter, then it will just keep going. It will not stop. So he called the first option the big crunch, when the universe will go and up to a certain point and then come back. And then maybe the other option where it will go on coasting. And he was asking the question, what is the reality? This is only 40 years ago. And at that time, we were not in a position to give the answer to this. The way you can do this is to use a subject which we call spectroscopy. What is spectroscopy? A lot of you have a background in many different kinds of sciences. You know that you use spectroscopy in almost all the sciences in different contexts, and that is you take light and you analyze the light into its different energies to find out what kind of energies have more are present in a certain form of light. And you can generalize the word light and use it for radiation, which means that it can be light that we see with our eyes or light that we cannot see with our eyes, which is to do with things like ultraviolet radiation, infrared radiation, X-ray radiation, and stuff like that. But if you take a galaxy and you take its light and put it through an analyzer like a prism or a grating, it will break out into a spectrum, and the spectrum will have certain features in it which will tell you what the chemical composition of that galaxy is. It's like a barcode. And that is because each element of the periodic table has a certain signature in the spectrum. So for example, the helium spectrum looks like that, the mercury spectrum looks like that, and then if you take a galaxy and you take its light and put it through an analyzer, you will find that in that spectrum, you will have these signatures from different elements at different places. And you can say that there is some part of the spectrum will have hydrogen, and they have sodium, or they have calcium, or magnesium, and things like that. Now, we also know that if the source of light, where the light is coming from, is actually moving, then these lines that you see in the spectrum also change in its energy or wavelength or frequency. And this is called the Doppler shift. So it's very similar to what happens in sound also, and that is if, for example, something that is emitting light comes towards you, the light's signature in the spectrum, which gives you a certain wavelength, will move and become something that is towards the blue, which means that its wavelength will reduce. And if it's going away from you, the wavelength is going to stretch, and it's going to become redder, and it's going to be larger. Now, this tells you how fast things are moving, right? And this was discovered quite early on in the late 19th century. And once that was found out, people started using the Doppler shift as a way to measure how fast things are moving in the universe, right? So if you take, for example, a hydrogen lamp that you can use in your physics or chemistry lab, and you can see certain lines that you can get out of it, the hydrogen alpha lines, or for example, the Balmer lines. And if you take that light from another object, like say the Orion Nebula, you will find that those lines have moved a little because Orion Nebula is moving with respect to us. If you look at a galaxy, then you will find that these lines have shifted towards higher wavelengths. And if you see more galaxies that look smaller, further and further away, you will see that these lines have moved further and further away. So this gave an initial indication that these galaxies are moving very fast, and they're moving away from us. And that gave a general idea that the universe might actually be expanding because all galaxies are moving away from us. But in order to establish this, there is one more thing that one needed to do, and that is to find an efficient way to measure distances to objects. As I said, that is going to be the theme of the couple of things that I'm going to talk about today. And one of the themes is, how do you measure a distance to a galaxy? You could always, if you knew how bright a galaxy is or how big a galaxy is, then by looking at it, you could measure how far away it is, right? But I told you the story of the sun and the moon. The sun and the moon are the same size on the sky, same angular size. They appear to be very similar, but of course, they intrinsically are very different in size. So this is why we would be completely wrong if we say the sun and the moon are exactly the same size. That's not right. So galaxies might have very different sizes or brightnesses. And so you have to find out how bright something is or how big something is by an independent measure to figure out how far away something is. Okay. So this was discovered by a remarkable astronomer at the beginning of the 20th century called Henrietta Leavitt. Henrietta Leavitt, working in Harvard at a time when women were not allowed to attend classes and sit for exams and get degrees at Harvard University or in Oxford University or in Cambridge University. These universities actually gave women the right to sit for exams only in the 1920s. Henrietta Leavitt and her group of women were working in Radcliffe College of Harvard University, where women could go and study, attend classes, but not sit for exams. They were doing some really amazing original research. And Harvard had a telescope in Arizona, another in South Africa, in which they were taking pictures of the sky several times, same part of the sky, several times a night for tens of years. And these remarkable women sat down and looked at pictures of the sky, pictures of these stars, and figured out that some of these stars were changing in brightness every few hours in a periodic fashion. And Henrietta Leavitt's group found this amazing variable star called Cepheid variables that actually go up and down exactly periodically in their brightness over days. They also found that the larger the star is, the more its period of variation. So by measuring its period of variation, they could figure out what the actual brightness of the star is. And thus, by measuring how much light we are getting from it, they could find out how far away they are. You understand? That's what I called a standard candle. You need some way of measuring how bright something is intrinsically, or how big something is. And once you know that, then you know how far away they are. So Henrietta Leavitt and her remarkable colleagues gave us this idea of finding these stars in galaxies, and then you know how far away the galaxy is. And as a result, another remarkable person came in the 1930s called Edwin Hubble, who made a very seminal measurement. Now, in the story of astronomy, you find some really remarkable people in the 20th century who came and contributed to astronomy, but they were not really professional astronomers to begin with. I told you about Herschel, who was a musician, but he was, making these amateur astronomy telescopes. Edwin Hubble was a lawyer who went to fight for the US in the First World War in France. He lay in the trenches for long nights, saw the skies and said, I'm in the wrong profession. I'm sorry. I'm not going to go back and be a lawyer. So in his 30s, after the war ended, he came back to Chicago, joined the university, and started taking lessons in astronomy and got a degree. And then he got his first job in the largest telescope in the world at that time, called Mount Wilson, which is outside Los Angeles, which actually had a spectrograph attached to the telescope to take spectra. At that time, remember, we didn't know that we live in galaxies. This is 1920s. So he remembered this guy called William Herschel in England, who had published a list of fuzzy stars that don't twinkle. So he said, what I'm going to do is I'm going to take this telescope and this spectrograph, and I'll try to find out what these fuzzy stars are made of. Chemical analysis, by taking spectra. And lo and behold, what he found was that not only he could find the chemical analysis of these fuzzy stars, he could find their velocities, because he found that those lines that I talked about have enormous shifts due to their motion. And he figured out that these things are moving very, very fast. And he found out that almost all of them are moving away from us. That is his first plot that he published in 1929. Many of you here are teachers of science. If any of your students give you a graph like this from their lab and draw a straight line through it, you would probably throw it away, right? He did this, and he was proved right that this is a line. And he found that what on the y-axis is the velocity of an object which he called a nebula, which is one of these fuzzy stars. And on the y-axis, on the x-axis is its distance. And he found that the velocity and distance were related. And he then said, then why are all these galaxies, all these things going away from us? Are they afraid of us? That is not right. So the only other thing is, if you think in the universe, if things are randomly moving, then if you look at the motions of galaxies, there should be equal number of things coming towards us and going away from us. That's not happening. So the only explanation is that the universe is expanding. And that became a very important piece of evidence, because at that time, unknown to him, on the continent, continental Europe, a big debate was going on between these people. Albert Einstein had published his general theory of relativity in 1915. After that, people had started taking that theory and applying it to the universe by doing solutions of the general mathematical theory that Einstein had published. Einstein hadn't done that. Other people were solving the equations. And one of the important people who had done this was his colleague called Joseph Lemaitre, who was a Jesuit priest, a Catholic priest, but also a professor of mathematics at the Sorbonne, at a time when Einstein taught briefly at the Sorbonne. They were colleagues. And he had solved Einstein's equations and found that it gave a very startling result. He found that the universe, if it goes by Einstein's theory of relativity, cannot stand still. It has either to contract or to expand. So he brought this to Einstein. And there was a famous conference in which he actually gave this paper. and said, you know, the universe has to expand or to contract. It cannot stand still. And Einstein got up after that, and Einstein didn't believe a word of it. Einstein really thought that the universe cannot really expand. How, you know, if it expands, what is it expanding into? Whole universe is expanding, right? So he told Father Lemaitre, you might understand your religion or your mathematics, but you don't understand physics. The universe cannot expand. So he said, if my equation is saying this, I will change my equation. So he actually, for a few years, changed his equation of relativity so that the universe doesn't expand. Unbeknownst to them, in St. Petersburg, Russia, another person, who's Alexander Friedman, came to the same conclusion. He wrote his paper in Russian in a Hungarian journal, which was not discovered for another 20 years. But both came to the conclusion that the universe is either expanding or contracting. And then Friedman died of tuberculosis at the age of 29. He didn't pursue it. But Lemaitre heard of Hubble's result. So both Lemaitre and Einstein went to meet Edwin Hubble in California, saw his data and saw, yeah, this is a good example. Look at this. The universe is expanding. It is not contracting, it is expanding. So what Einstein had originally predicted is right. So that gave us this startling result, which even when I teach in my class for first year, second year students, they all have trouble understanding. And I'm sure everybody here would as well if you're not familiar with it. And that is, what does that mean? What is the universe expanding? Now, in the textbook, you see pictures like this, where they say, imagine the universe is like a balloon, and all the galaxies are spots on the balloon. And as the balloon expands, the spots are all going away from each other, right? There's a problem with that, because then you can ask the question, who's blowing into that balloon? So that's not really a very good, I don't like that analogy at all. I like the analogy below, where maybe, I know a lot of you might have made bread or cake or something like that. You put some yeast, you put some maida, and you put some maybe seeds or raisins in it, and then you put it in some tandoor or an oven where it starts rising. So the bread is expanding, so the universe is expanding, and then the seeds or raisins inside it are going away. They're not expanding, but they're going away from each other, right? So think about that. That's, in a three-dimensional sense, is exactly what's happening. The universe, what Einstein is saying, that according to his theory, which describes the nature of space, space itself is expanding. And the galaxies are embedded in space, and they're going away from each other. It's like this. Right? And just because Hubble found that the further away a galaxy is, the more its velocity, that is entirely consistent with this picture. Now, so let's go back to, in the last few minutes, Hawking's question. If that is so, you have discovered the past of the universe. What is the future? When the universe is expanding, so what Lemaitre had said is that if the universe is expanding, then if you think of it as a movie and you rewind it, then in the past there would be a time when everything was together. So the universe had a beginning, right? And that's what's called the Big Bang. There was no bang, but there was a beginning. And now it has come to this stage. This caused a huge problem in many people. And this is why Einstein, for example, accused Father Lemaitre of thinking such a model because of the fact that he was a priest, a Christian priest. And the Bible seems to say that God created the universe at one time. And he's saying you're being biased by your religion. I worked for many years at Ayuka, Pune with Jayant Narlikar, who recently just passed away. And Professor Goswami was a very good friend of Jayant Narlikar and had come to meet him many times. Jayant Narlikar believed, till the day he passed away, in a universe that did not have a beginning. It had infinite time and space. And there are many people who can believe that, but he was in a minority. Because we now have quite a lot of evidence that the fact that the universe did have a beginning and is expanding. So then the question is, what happens in the future? And as Hawking said in that book that he wrote in the 80s, that if the universe has enough matter, just like if you take something and throw it up, because the earth is pulling it back, it comes back. Now, if you throw it up, you will find that it slows down and then it comes back. But if you throw it very, very fast, then it can even escape the gravity of the earth and go. And similarly, if you don't have enough matter, the universe must have had an impulse at the beginning. It will go expand forever, or it will come back, right? So it turns out, it all depends on what the universe is made of. We have to find out what the universe is made of and how much matter and energy there is in the universe in order to answer that question. What will happen to the universe? Very interesting relation. But you can ask the question, is the universe made up of things like us? We are made up of proteins, which have these elements, carbon, oxygen, hydrogen, etc. And they are all coming from that periodic table, right? And everything we see around us are made up of things that are in the periodic table. So the first question you can ask, is the universe made up of things that are in the periodic table? And that is what we thought till the 1970s, when we started discovering that the universe actually, most of it is made up of something else. And this is one of the biggest surprises astronomy, astrophysics has had in the last 50 years or so. So I'll give you, there are many ways to find out the nature of the matter and energy in the universe. And I'm going to talk about dark matter and dark energy in brief segments, because of course we don't have too much time today. I'll give an example of how we can find out the matter that makes up of the universe. You can assume that the matter that makes up the universe is what you see in the stars and the galaxies around us. But what about matter that doesn't give out light? It will still act through gravitation, pull things. And so you can find out the presence of such matter by looking at gravitation and ask the question, is there enough matter in the universe that is not giving out light, but is dark? And it turns out, and even when I was a student, not so long ago, I'm not that old, when I was a student, it was not known whether the universe has too much dark matter or not. So here is an idea of Einstein. Einstein's big idea in the general theory of relativity was that the universe, the space that makes up the universe, actually it can be flat if there is no matter there. And if you have light going through the universe, it follows space and goes in a straight line. However, if you have any matter there somewhere, like the sun or the moon or a galaxy, then it will bend space locally. And then as light goes through space, it will go along the bent space. So you'll see that light bends, right? And so if an astronomer is observing a star or a galaxy from which light comes to them, but comes around something, right, and it bends, it will see it at a different place, right? So can you prove this? And yes, within a few years of Einstein actually proposing this, there was an experiment done by Eddington that showed that the sun, the stars that you see around the sun, actually move to a different space when the sun is not there in the sky. But its proof really came in the 1970s and 80s through this idea called gravitational lensing, which means as follows. So you have, now we know that the universe is very big and is full of galaxies. So say we have a galaxy at the end of, very far away in the universe, and we are observing it from here. In the middle, there is a whole bunch of galaxies sitting there, right? You can ask the question, do those galaxies have only the matter that you see in the light? Or is there other stuff in there, in between those galaxies? You can see that that's what we've portrayed here as a dark thing, dark matter. How can you ask the question? You can find out how the light, as they go by those galaxies, how much they bend. Now, can you detect this bending of light? You can see that as the galaxy, the light comes from far away in the universe and comes to us, they bend. And so as they bend, they do a very interesting thing. If you have a galaxy very far away and its light is bending, I start seeing it somewhere else, right? But I can see light from the same galaxy coming to me from another angle. You can see from here. And so I see it somewhere else. And if they're two perfectly aligned, I will see a ring. This is called an Einstein ring. This is a prediction of the Einstein's theory of relativity. That if the two things are aligned, you will see everything that is far away in the form of rings. And if they're slightly misaligned, that ring is going to break up into many, many objects. In the 1990s, we started seeing these rings. When the Hubble Space Telescope went up and started making high-resolution images, we started seeing that very far away galaxies were all seen as rings. I give two examples here. And not only that, we started seeing that galaxy images will be distorted because all this light that is coming to you is passing all other matter that is in the intervening space and is not coming to you straight. It is coming in a very complicated fashion. Here's a good example that my friend Sarah Bridle actually made in a simulation to show what happens if, for example, an unseen dark matter blob in front of her face, a picture of her face, as you're looking at her. And you'll see that the light, as the light comes to you, it will move, it will bend in such complicated fashion that you're going to see in that image many copies of her face, all in different orientations and all distorted. We started seeing this as the Hubble Space Telescope went up in the 1990s. As you can see, here is a picture of a cluster of galaxies, and you see these little streaks all over the place. We have now shown that many of these little streaks, this arc, that, they are the same galaxy. You see them in 5 different places. You can prove that. You can see these, how distorted galaxy images are. Now, what happens when you see these things in the sky? You can measure the amount of matter needed to cause these distortions in these images. You are seeing mirages in the sky. No galaxy that is far away, the images that you're taking actually looks like what you see. You see a very distorted version of everything. But it allows you to find out how much matter there is in the intervening space. And it turns out there is about a 50 to 100 times more matter that is dark, that does not produce enough light. And it is all through space, all over the universe. It gravitates, so it bends light, but it does not have stars, and it does not show you. So this is called dark matter. And when I finished my PhD and started working as a professional astronomer in the 1990s, this was the picture when suddenly people started talking about dark matter. How do you find out how much there is? And where do you find out? And we all started working on this stuff. And then, very fast, the story changed again. So in the mid-90s, we knew that we really wanted to know how much matter there is in the universe. And we found that the universe is not dominated by matter. The universe does not have the amount of matter that we expect, even if you calculate the dark matter. And we started to understand that there is something even more than not just matter that is in the stars, matter that is dark, but something else. How do you find out? And I'll spend the last 5 minutes, and then I can see if you can ask questions, to to tell you what happens in 1995. So here is a recap. Hubble publishes in 1929 a graph which gives you a relation between velocity and distance. And it says it's a linear relation. By the time we came to 1995, there was a telescope that was launched in the sky, in space, called the Hubble Space Telescope, named after Hubble, with the view that in the past 5 years, all it's going to do is to find these Cepheid variable stars, the stars that pulsate, and so you can measure distances, to find out these stars in external galaxies, and then extend this graph to see what happens to this Hubble flow, Hubble expansion. Because, interestingly, this plot, which plots velocity versus distance for galaxies, the slope of this plot tells you how fast the universe is expanding, that slope. Now, remember what Hawking said? The universe is full of matter. So, the universe's expansion is going to slow down. So, in the past, the universe must have been expanding faster. Right. In astronomy, we have a very interesting thing. If we look very far away, we are looking at things that are in the past. Because light takes a lot of time to come to us. So when I'm looking at the Andromeda galaxy, which is 2 million light years away, I'm seeing it as it was 2 million years ago. Right? Because the light has only reached me. I don't know whether that galaxy even exists now. So, if you want to know what happened in the past of the universe, you have to look further and further and further and further away. That's all you have to do. Build big telescopes, look further away. So my question here is, what will happen if I take not just Hubble's galaxies, but very far away galaxies? Then slowly I will begin to see the expansion of the universe changing. It can't be the same. It has to slow down because all the matter will pull it back. So that is what happened in the 1990s when the Hubble Space Telescope went up. It found Cepheid variables in various galaxies, and we found that this wonderful graph that Hubble had, that scatter had now come down, nice little straight line, and it showed that no change in the rate of expansion of the universe out to what we saw there. That little yellow spot that you see, right at the corner there, is the extent of the graph that Hubble had measured in 29. Now, in 1990, we could measure 50 times more. No change in the expansion of the universe. Remember, why am I saying this? I want to know what's going to happen in the future. And Hawking is asking, will the universe slow down, or will the universe come back like that? Or it will expand forever? Then, in 95, a certain discovery was made that led to a Nobel Prize. A new standard candle was discovered. Not Cepheid variables that was discovered in 1910, but a new kind. And so remember standard candles? This was, and if you are getting very impatient, I only have 3 minutes left. This was a very, very interesting thing that people found, and that is what is known as a supernova, a type 1 supernova. A star, at the end of its life, explodes. Some stars explode such that the outer bits explode and the inner bits are left behind. They are called type 2 supernovae. But there are some stars that fully explode, nothing is left behind. They are called type 1 supernovae. And these supernovae, stars that completely explode, were found in 95 to be standard candles. It means that if you could find how, and you could see them, when the star explodes, you see them as appearing, like you can see, for example, here, suddenly something will appear, a star is exploded, and a month later, it will go away, right? So what it does is it gets bright, and then fades away. if you can find the peak brightness that it reaches, that is a standard candle, which means that that tells you exactly how bright that thing is, which means you can measure the distance to the galaxy. So what Hubble's telescope could not do, it only had extended Hubble's experiment to about 10 times the distances. We now can extend that to 1,000 times the distances of Hubble, because these supernovae are so bright that they can be seen at the end of the universe. And so this whole exercise started. We all took part in it. We did this automatically with taking lots of pictures of the sky. We had dedicated telescopes, and these dedicated telescopes went and took photographs of the sky 100 times, 100 photographs, and come back the next day, 100 photographs, just to search for these supernovae. Where are they appearing? Where are they appearing? And big telescopes, like the telescope I showed you in that picture where I showed you the Milky Way, that 4-meter telescope, famous telescope, was completely converted to doing just this. And then we discovered 1,000 such supernovae, going up to very, very far away. I'm going to skip that. And I'm just going to show you, this was, again, showing you an old plot of Hubble 1929. Remember, in the 1990s, this is where it became. And what we are trying to find out was that if we look very far away, where is that slope going to go? It's going to be higher in the past, right? Because the universe is supposed to slow down. That's what Hawking said. And so that graph is supposed to move up like that in the past if you go further and further away. And with the supernovae, we found that it's completely the opposite. So we found that the universe was expanding slower in the past. And this means that the universe is not slowing down, it is expanding, but it's speeding up. Now, no physical process that we knew so far does that. That is actually prevalent over large distances. You know, electrical charges repel. But that is a very small scale process. You can't have galaxies repel each other. But it looks like the universe is expanding in such a way that nothing is bringing it back. Gravitation only attracts. Gravitation doesn't repel. So this is what keeps us in business. I now know that astrophysicists will not be out of a job in the next 100 years because the whole picture has changed now. We know that the universe is made up. First of all, somebody told us that the universe is not made up of something that makes me up, periodic table. It's dark matter. And now, this is telling you that the universe is not even made up of matter. It is made up of something that repels. Matter attracts. So now this is the view of the universe. Ordinary matter, ordinary by meaning what you and I in this chair and this water is made up of, makes up 5% of the universe. But 20% of the universe is made up of this dark matter which doesn't have any light, doesn't interact with ordinary matter. We have no idea what it is, but it gravitates, it pulls. But then 70% of the universe is made up of something that pushes, doesn't pull. And it is making the universe go faster and faster. And imagine, I'm so sorry that Stephen Hawking is not alive now, but if Stephen Hawking wrote his book now, half of his book he would not have written, because half of his book was about the universe coming back. That's not going to happen, because it's speeding up right now, right? So there is no way the universe is having that big crunch. But the interesting thing is that the universe now is going to expand forever and become a very large and lonely place. And people are trying to figure out many things. One is, what is the long-term, future of this universe? Why? what is this thing that is making the universe accelerate? We call it dark energy, but that's a horrible name. Because, okay, it's dark, because we don't know. Anything that we don't know is dark. And it's not matter, so call it energy. We have no idea what that is. But physicists are very, very hard working to figure out what this dark energy is and what it will do. So I wanted to give you the impression that, I was telling you that 300 years ago, we thought the universe is 6,000 years old. 100 years ago, we didn't even know that the universe is made up of galaxies, and we didn't even know how old the universe is. And then we figured out the universe is about 14 billion years old. The Earth is about 4.5 billion years old. All that is 100 years old. Now I'm telling you that the universe is made up of stuff that is not even matter, and we don't understand it at all. And we are left with this, I'm sorry to do this, but I'm leaving you with a very uncomfortable notion that we really don't know. Other than the fact that the universe is expanding and it's accelerating, we don't know why it is doing so and what's going to happen to it. And that makes science so exciting. It's because there is no chance, when you think you've understood everything, somebody comes in and actually can change the entire thing. And you are faced with the situation understanding, oh, there's a huge amount of work to do. I'll stop there. Thank you very much. I don't know whether you have enough time to ask any questions. I don't know whether the organizers want that, but I'm here. Thank you. Does anybody have any microphones? I'm sorry, I don't know how long you want to carry this on. I'm here.
Sir,
Yes.
this is a layman's question.
Yeah.
But does the answer to this lies in additional dimensions beyond the observable four?
Yeah, that's a very, very good question and very, very good answer. There are many, many people, of course, who are trying to find, because we are clutching at straws right now, but for a long time, people have sought the solution to such mysteries in additional dimensions. For example, when the dark matter was first discovered, people thought that the origin of dark matter was from additional dimensions. We are three-dimensional being, but there might be others. So there are people, for example, there's something called the M theory, as you know. M theory says the universe probably has 9 dimensions. We only experience 3 of them, but other universes which are there have larger dimensions and they interact with us. Very good, but nothing has really been worked out. And I'd be very happy if somebody can come up with a theory. People have come up with theories. The problem is such theories don't have any tangible predictions that can be experimentally verified. Right? So you can say universe has 9 dimensions. How are you going to experimentally prove it? Give me a test. I will perform the test. That's the idea. Anybody else?
Thank you very much, sir, for this wondering lecture. Actually, initially it was known to us that in naked eyes we can see some number of galaxies in the universe. And after that, when some powerful telescope came, it was found that what we can see, it should be many times greater than that. Later on, when more powerful telescope came, you said, no, it is 10 times larger than that. My question is, whether actually till today, we exactly can know this universe, or even if in future, some more powerful telescope comes, then boundary may be further expanded, and there may be some other unknown things still waiting for
Yeah,
us.
that's a good approach. The thing is, you can ask the question how well we know at least, 1/10 of the universe, not the whole universe. And I think the nearest 1/10 of the universe or 1/5 of the universe has been very, very well explored by the telescopes that exist. The biggest telescopes in the world actually go down to detecting very small galaxies in the nearest, maybe 1/5 of the universe. And so you can ask the question only based on that. If you want to go much further and look at the end of the universe, then you are right. There might be bigger telescopes that can come and give us more information. But that's how science progresses, right? I mean, sometimes science, I showed you Hubble's plot of all that scatter, and he made a very bold prediction based on that, and it has survived. So all I'm telling you now is based on what we know. And our instrumentation is much better than what Hubble had 100 years ago. And we are very confident that we know quite a lot about the nearest part of the universe. We don't know much about the edge of the universe, how far away galaxies go, what were the earliest galaxies. Still, there's a lot to be measured. So to some extent, you're right. We will discover new things, and that will continue to change our view of the universe. But what I told you today is based on a volume of the universe that we think we understand quite well. Okay, I think it's getting quite late. People are leaving. I'm happy to talk to people. I'm around. Thank you. Yes. I don't know much about religion. I can't say much about religion at all. But I just told you what we have measured in terms of the motion of the galaxies. And that's all I can do. And we now find that the galaxies are moving away from each other, and there is no chance they're going to come back. So if some scriptures has said something about that, well, it is now showing that that's not going to happen. But going back to what you're talking about, the question of what the nature of space and time was before the Big Bang is absolutely not something we can ask. Because our current knowledge is based on our perception of the current universe. You can ask the question, what's in the next room? You can infer what's in the next room, but you can't say for certain what's in the next room because you're not seeing it. And if the next room is such that you will never see it, then you cannot have a scientific inference that tells you what is there. So, because there is absolutely no chance of us designing an experiment that will tell us what was there before the Big Bang, modern science cannot say anything about it. Okay, thank you very much. Thank you. Let me see if I have everything. Thank you. Thank you. Thank you. I'm amazed that so many people patiently stay there.
From that engaging storytelling on the evolution of the earth and the universe to your insights on its future, the implications of the dark energy. Thank you, Professor Raychaudhary, for that very thought-provoking lecture. May I now request the Honorable Vice Chancellor of Cotton University, Professor Ramesh Chandradeka, to say a few words on the occasion. We are almost about to end the session. After the closing remarks, I request our audience to be seated for some time. Thank you so much.
Namaskar, Honorable Vice Chancellor of Ashoka University, Professor Raychaudhary, President of Assam Science Society, Dr. Kumar Mishra, Dr. Goswami Baido, Secretary Assam Science Society, Sri Mrinal Hazarika, Monsor Honmukhot Mor Shikkaguru Promukhe Cotton Collegeor retired Shikkok Shikkayatri Cottonor Bortoman Cotton University Shikkok Shikkayatri Mor Moromar Satro Satri Bondhu Bandhabi Hokol aru upasthit rais as Anil Goswami sir tekhete fellow of Royal Astronomical Society he their prestigious award eta tekhete paisile aru ajir jitu boktika Raychaudhary hisabe dangi dhurile etu astronomy uporot upojukto eta bokta ejon ami paisu aru Kumar Mishra debe বহু দিনৰ পৰা মোক কথা পাতি আছে যে আমি কাক মাতিম কাক নিমন্ত্ৰণ কৰিম বহুত ডিসকাশনৰ পিছত we found Professor Raychaudhary sir from Ashoka University. Sir, thank you very much for your wonderful lecture. আমি যেতিয়া thermodynamics পঢ়ো thermodynamics second law of thermodynamics entropy ৰ কথা কওঁতে things are expanding and if the entropy is more things become more stable. Then it was related to inverse. Inverse is also expanding for its stability. I think sir has explained very beautifully, starting from Hubble graph. So thank you very much, sir, for your wonderful lecture. Anil Goswami sir class ami poa nai more chemistry major. Kino pass course asile physics. Kino sare amar class poa nasile. Kino eta kotha kobo lagibo department ফলে চকু দিলে সাৰক দেখা পায় আমাৰ ডিপাৰ্টমেন্ট আমাৰ কেমিষ্ট্ৰি ডিপাৰ্টমেন্টৰ ওচৰতে ফিজিক্স ডিপাৰ্টমেন্ট আমি সেইফালে যদি চাওঁ সাৰৰ উপস্থিতিটো খুব বেছি হৈছিল এবাৰ আমাৰ প্ৰফেসৰ দেৱজিৎ শৰ্মা কৈছিল তেখেত আছেনে নাজানো সাৰে তাৰমানে কেতিয়াবা দিল্লীত থাকে সাৰৰ ইপিনে কটনৰ ক্লাছ থাকিলে তাৰমানে ফোন কৰে যে তোমালোক থাকিবা মই গৈ আছো ক্লাছ কৰিম তাৰমানে এয়াৰপোৰ্টৰ পৰা আহি তেখেতে ডাইৰেক্ট কটনলৈকে আহে কটনৰ প্ৰতি তেখেতৰ তাৰমানে যিটো বিলংগিংনেছ আৰু তাৰমানে বেছিভাগ সময় তেখেত আৰু অৰূপ মিশ্ৰই দেৱে কোৱাৰ দৰে তেখেতে কিমান কিটা ইনষ্টিটিউট বনাইছিলে অসমত তাৰমানে প্লেনেটৰিয়াম যিটো ৰিজনেল সায়েন্স চেণ্টাৰ সেইটো এতিয়া নেশ্যনেল সায়েন্স চেণ্টাৰ হৈছে এইটো চেণ্ট্ৰেল অৰ্গেনাইজেশ্যন IISCৰ বৰাগাঁও সেইটো প্ৰথমে Assam Science Society এটা ইনষ্টিটিউট হৈ থাকিলে পিছত গৈ হেতু এটা আকৌ নেশ্যনেল ইনষ্টিটিউট হৈ গ'ল প্লাজমা ইনষ্টিটিউট অফ প্লাজমা ফিজিক্স সেইটো এটা নেশ্যনেল ইনষ্টিটিউট গোটেইকেইটা তাৰমানে এটা আমাৰ ৰিজনেলৰ পৰা গোটেইকেইটা নেশ্যনেল ইনষ্টিটিউট ছাৰে বনাইছিলে এজন মানুহে বনাইছিলে তাৰমানে সেই কথাটো ক'ব বিচাৰিছোঁ ছাৰে কিমান তাৰমানে অসমৰ কাৰণে কিমানখিনি দি থৈ গৈছে আৰু গৱেষণাৰ ক্ষেত্ৰত তেখেতে ফিজিক্স ডিপাৰ্টমেণ্টৰ তাৰমানে কটনৰ ফিজিক্স ডিপাৰ্টমেণ্ট এটা সময়ত খুব বিখ্যাত আছিলে কুৰুৰি ছাৰ এতিয়াও আছে তেখেতৰ তাৰমানে more than 150 পাব্লিকেশ্যন ফ্ৰম কটন কলেজ সেইটো এটা ছিগনিফিকেণ্ট ছাৰো বহুত গৱেষণা কৰি আৰু ছাৰে যিটো বিজ্ঞানৰ যিটো চাইণ্টিফিক যিটো মাইণ্ডছেট তাৰমানে আমি চাইণ্টিফিক টেম্পাৰ যিটো সমাজৰ মাজত জগাই থৈ গৈছে সেইটো খুব প্ৰশংসা কৰিবলগীয়া আৰু ছাৰে তাৰমানে যে WWFৰ নৰ্থ ইষ্টৰ যিটো ফাউণ্ডাৰ মেম্বাৰ তেখেতসকল তাৰ পৰাই গম পায় তেখেতৰ সমাজৰ প্ৰতি কিমান তাৰমানে এটা হেৰি সজাগতা আছিলে আৰু বিজ্ঞানৰ বস্তু লেবৰেটৰীৰ পৰা যে সমাজত যাব লাগে সেইটো খুব ছাৰে খুব ধুনীয়াকৈ দাঙি ধৰিছে ছাৰে তাৰমানে ছাৰ এটা এক্সাম্পল তাৰমানে মই আৰু দীঘলীয়া নকৰোঁ আজি আমি খুব সৌভাগ্য যে আমি উই গট প্ৰফেচাৰ ৰায়চৌধুৰী এজ এ স্পীকাৰ আৰু মই আপোনালোক সকলোকে ধন্যবাদ জ্ঞাপন কৰিছোঁ যে আজি হলটোত আমি এটা সন্দেহ আছিলে যে আমাৰ হলটো ভৰ্তি হ'বনে নহয় তেওঁ অৰূপ মিশ্ৰই বাৰে বাৰে কয় তুমি কিন্তু হলটো ভৰাব লাগিব দেই তাৰমানে এইটো খুব সুন্দৰ আপোনাক সকলোকে ধন্যবাদ জ্ঞাপন কৰিছোঁ যে আপোনালোকে সময়ত আহি আৰু আমি 2 বজাত আমাৰ হল ভৰ্তি আমি অনুষ্ঠানটো আৰম্ভ কৰিব পাৰিছোঁ তাৰ কাৰণে আপোনাক সকলোকে ধন্যবাদ জ্ঞাপন কৰি মই মোৰ বক্তব্য সামৰিছোঁ ধন্যবাদ
Thank you so much, sir. We would like to hear a few words from our August gathering here today. To start with, I would request former head Department of Chemistry of erstwhile Cotton College, Dr. Soitendra Kumar Chaudhary, sir, to say a few words.
Respected dignitaries, মোৰ শিক্ষাগুৰু আছে ইয়াতে আৰু বন্ধু বান্ধৱীসকল এতিয়া মানুহ কমি গৈছে কিন্তু মোক ক'বলৈ দিয়া হৈছিল আৰু মোক সুধিছিল কম নে নকম মই কিন্তু কম কাৰণ কেইটামান দিশ আছে যিখিনি দিশ মই ইয়াত কওঁতে যে সামৰা নাই যেন লাগিছে ছাৰৰ লগত যিটো সান্নিধ্যত আছিলোঁ 90s পৰা শেষলৈকে মোৰ সৌভাগ্যক্ৰমে মই সেই সান্নিধ্য পাইছিলোঁ ছাৰৰ চিন্তাধাৰা মই খুব চমুকে ক'ম মই অলপ দীঘলীয়াকৈ ক'ম বুলি ভাবিছিলোঁ কিন্তু আপোনালোকে যিকেইজন আছে অকণমান শুভ মই এটা প্ৰস্তাৱো দিব খুজিছোঁ ইয়াতে আপোনালোকে কৈ আছে কটন কলেজৰ যে 1993 হৈছিল নহয় এইটো চেণ্টাৰ অফ এক্সেলেঞ্চ 92 এতিয়া গোটেই কটন কলেজৰ ছাৰে যিটো হাৰে হিমজুৱে ভাল পাইছিল সেইটোত গোটেইখিনি কথাখিনিত প্ৰকাশ পোৱা নাই যে ছাৰে যিটো উদ্যমতে আচলতে PG ষ্টাৰ্ট হৈছিল ফিজিক্সৰ পৰা 1992 22 ডিপাৰ্টমেণ্টত আমাৰ PG হৈছিল আৰু ডেট বিকামছ এ চেণ্টাৰ অফ এক্সেলেঞ্চ অলৰেডি অৰূপ মিশ্ৰই কথাটো কৈছে কিন্তু তাৰ পিছত যেটো কথা আছিল তাত ভিতৰুৱা আৰু কিছুমান কথা আছে ছাৰে তেতিয়া সপোন দেখিছিল কটন কলেজখন উন্নীত কৰিব লাগে ইয়াক প্ৰথমতে অটোনমাস কৰিব লাগে তাৰ পিছত ইউনিভাৰ্চিটিলৈ লৈ যাব লাগে এটা 90s কথা কৈ আছো আৰু সেই সময়ত ইট হ্যাপেন্স দ্যাট 92-93 ভিতৰত মই আৰু তাৰক চৌধুৰী ছাৰ প্ৰফেসৰ তাৰক চৌধুৰী মেথামেটিক্সৰ হেড আছিল আমি দুজন কিবা কাৰণত সেইবাৰ আসামিজ স্ক্ৰিপ্টত IITৰ পৰীক্ষা হৈছিল স্ক্ৰিপ্ট চাবৰ কাৰণে এক্সামিন কৰিবৰ কাৰণে IIT খড়গপুৰলৈ গৈছিলোঁ ছাৰে তেতিয়া আমাক মাতিনি কৈছিল তোমালোক গৈ পেলাই যাদৱপুৰ ইঞ্জিনিয়াৰিং কলেজটো তেতিয়া অটোনমাস হৈছিল সেইটো খবৰ লৈ আহিবাচোন কেনেকৈ কৰিব পাৰি মানে অটোনমাস কৰি ইউনিভাৰ্চিটি কৰিব পাৰি নেকি তাৰপিছত আমি গ'লোঁ তাৰ পৰা গৈ পেলাই এটা ৰিপৰ্ট হিচাপে ছাৰক দিছোঁ আৰু তেতিয়াই ছাৰে দ্যাট ইজ ইন 90s কটন কলেজখনক আপগ্ৰেডেশ্যন কৰিবৰ কাৰণে খুব চেষ্টা কৰিছিল আনফৰ্চুনেটলি ছাৰৰ যিটো চিন্তাধাৰা কিমান দূৰলৈকে ভাবিব পাৰে সেইখিনি ভাবিব পৰা আমাৰ শিক্ষাগুৰু বৰ কম আছিল সেই সময়ত শিক্ষকসকলৰ ভিতৰত তেখেতসকলে এইটো বাধা দিছিল আৰু যদি সেইটো হ'লহেঁতেন আমাৰ একচুৱেলি কটন কলেজ যদি উন্নীত হৈছে 2017হে কটন কলেজ ইউনিভাৰ্চিটি হৈছে 2011ত কটন কলেজ ইউনিভাৰ্চিটি হোৱা নাই কোনোবাই কৈছিল 2011ত কটন ইউনিভাৰ্চিটি হৈছিল কটন কলেজখন ইউনিভাৰ্চিটি হোৱা নাছিল দ্যাট ৱাজ এ affiliated college of Cotton University. Actually, Cotton College upgraded হৈছিল to University 2017. আৰু ছাৰে সেইটো বিচাৰিছিল 90s আৰু আপোনালোকে ভাবকচোন যে যদি সেই সময়ত কটন ইউনিভাৰ্চিটি হ'লে এতিয়া কি হ'ল এইখন এতিয়াতো বহুত দেৰিকৈ হ'ল তাৰপিছত আৰু কেইটামান কথা কোৱা নাই যে ছাৰৰ যিটো কৈ আছে ইনষ্টিটিউশ্যন বিল্ডিং হয় কিন্তু কটন কলেজৰ ওপৰত তেখেতৰ যিটো অৰিহণা বহুতবিলাক বস্তু নাজানে ইয়াত কিছুমান ছাৰৰ ইমান জ্ঞান আছিল মই মোৰ এটা প্ৰবন্ধত লিখিছোঁ এই প্ৰবন্ধৰ কথাখিনি মই ইয়াত নকওঁ আপোনালোকে পঢ়ি চাব ইভেন কটন কলেজৰ কেমিষ্ট্ৰি ডিপাৰ্টমেণ্টত আমি যিটো ৰিচাৰ্চ লেবৰেটৰী গুৱাহাটী ইউনিভাৰ্চিটিৰ এফিলিয়েটেড এইটো 1996 হৈছিল এইটো কিন্তু অৰিহণাটো গোস্বামী ছাৰৰ তাৰপিছত সেইদিনা আমাৰ অৰূপ মিশ্ৰ কৈছে FBS একো বুজি নাপাব ছাৰৰ যিটো উদ্যমিতা যিটো এণ্টাৰপ্ৰেনাৰশ্বিপৰ কথা যিটো শিক্ষা অসমত এণ্টাৰপ্ৰেনাৰশ্বিপ গোটেইখিনি ডেভেলপমেণ্ট ছাৰে কৰিছে যিটো আমাৰ ইনষ্টিটিউশ্যন আছে এণ্টাৰপ্ৰেনাৰ ইনষ্টিটিউটত আছে সেইটো বেলেগ বস্তু কিন্তু 90sত যেতিয়া মানে গোটেই ভাৰতবৰ্ষতে এণ্টাৰপ্ৰেনাৰশ্বিপৰ ওপৰত বহুত বেছি কাম হৈছিল আৰু 1993ত বোধ হয় ছাৰ আমাৰ প্ৰিন্সিপালৰ পৰা এষ্টেকৰ ডাইৰেক্টৰ আছিল আৰু তেতিয়া তেখেতে কটন কলেজটো তেখেতৰ মনত আছে যে এণ্টাৰপ্ৰেনাৰশ্বিপ কাম কৰিব লাগে তেতিয়া ফাৰাডে বাইচেণ্টাৰী ছায়েন্স পাৰ্ক মোৰ তেতিয়া ৰিচাৰ্চ লেবৰেটৰী ছাৰৰ কাৰণে হৈছে মই তাতে কাম কৰি আছিলোঁ গধূলি এদিন আহি পেলাই কৈছে যে তুমি কটন কলেজত এইটো মোৰ হৈ পেলাই কৰি দিয়া ফাৰাডে বাইচেণ্টাৰী তাৰো ইণ্টাৰেষ্টিং ফাৰাডে বাইচেণ্টাৰী ছায়েন্স পাৰ্ক ছাৰৰ মূৰত কি বস্তু নাথাকে সেই বছৰটোত আচলতে ফাৰাডে বাইচেণ্টাৰী হৈছিল চেলিব্ৰেশ্যন হৈ আছিল গতিকে নামটো দিছিল ফাৰাডে বাইচেণ্টাৰী ছায়েন্স পাৰ্ক মই সুধিছোঁ ছাৰ আপুনি নামটো ক'ৰ পৰা আহিলে বোলে সেইটো সেই সময়ত বাইচেণ্টাৰী হৈ আছে ছায়েন্স পাৰ্কৰ পৰা তেখেতে সেই সময়ত কটন কলেজত CFTRI মানুহ আনিছিল চেণ্ট্ৰেল ফুড ৰিচাৰ্চ ইনষ্টিটিউট মাইচুৰ আমাৰ কিমান কামত জয়দীপ বৰুৱা বৰ্তমান ডিৰেক্টৰ আছে তেওঁ আছিল ইয়াতে নহয় জয়দীপ মনত আছে নহয় CFTRI মানুহে ভাবিব নোৱাৰোঁ যে কিছুমান নাভাবা কাম কৰে কিন্তু তাতে চেচ হোৱা নাই আপোনালোকক আৰু ক'ব লগা আছে ছাৰে যে কথাবিলাক ভাবি আছে বহু দূৰলৈ ভাবিছে আচলতে আপোনালোকক কওঁ ইয়াতে কোনেও ইয়াতে উল্লেখ কৰা নাই এণ্টাৰপ্ৰেনাৰশ্বিপ ডেভেলপমেণ্ট চেল that is a big project from DST it is granted for reputed engineering college and universities এতিয়া সেই বস্তুটোত IIT মাদ্ৰাজ বহুত ডাঙৰ হৈ গ'ল তেতিয়া ছাৰে সেইবিলাক কথা ক'বৰ পৰা কেনেকৈ খবৰ পায় আনি পেলাই এই যে কামটো কৰিলে 93ৰ পৰা FBS পাৰ্ক মানে কটন কলেজৰ কিছুমান এক্সপিৰিয়েঞ্চ গোটাই ল'লে 2000ত ছাৰে লগ লাগি আমাৰ লগত দিয়া আমি এতিয়া DSTত এপ্লাই কৰোঁ DSTত এপ্লাই কৰি দেখিছে কৰি পেলাই তাতে তেখেতৰ বহুত চিনাকি আছে চব ইনফৰমেশ্যন নলেজ আছে যে নৰ্থ ইষ্ট ৰিজনত কোনো ধৰণৰ EDC পোৱা নাই কেতিয়াও গতিকে আল্টিমেটলি উই প্ৰিপেয়াৰ্ড এ প্ৰজেক্ট ছাবমিটেড ছাৰে লাগি আছে নৰ্থ ইষ্টত কিয় নিদিব আল্টিমেটলি 2002ত the Cotton College, that is a general college, it is an exceptional thing. Kunu university, reputed university, aru reputed engineering college or pisot, prothom EDC dise Cotton College. Aru tate 30 lakhs, 2030 lakhs bahut beshi bod hoy. Tate aru eta kotha, kisumane bhabibo pare, research project ot bahut beshi poisa pai. Yat instrument nai ako. Aru tate aru eta kotha, okoman apnar somoy lওঁ, ছাৰ কিমান দূৰ ভাবিব পাৰে যে এনেকুৱা এটা ইনষ্টিটিউট যেতিয়া গ্ৰ' কৰিব লাগিব তাৰ ইণ্ডিপেণ্ডেঞ্চ থাকিব লাগিব কটন কলেজ এখন আপোনাৰ কেনেকুৱা এইটো হ'ল এটা ষ্টেটৰ আণ্ডাৰত গতিকে ছাৰে প্ৰথম মিটিংখনত কেইজনমান মানুহ মাতিছিল মই এতিয়া কওঁ এটা প্ৰফেচৰ গৌতম বৰুৱা IIT ডাইৰেক্টৰ শান্তিকাম হাজৰিকা এইবিলাক ছাৰৰ মগজত আহিছিল আহি পেলাই আমাৰ প্ৰিন্সিপাল জয়মতী মেধি আছিল বহাই পেলাই কৈছে কি তেখেতৰ দ্বাৰা আমাৰ প্ৰফেচৰ গৌতম বৰুৱাৰ দ্বাৰা ক'লে যে ইণ্ডিপেণ্ডেণ্ট হ'ব লাগিব মানে এই ইনষ্টিটিউশ্যনটো কলেজে নহয় তেখেতসকলৰ মতে কৰিব লাগিব আৰু আমি এনেকুৱা ছাৰ আহি থাকে আমি এনেকুৱা এটা ইনফ্ৰাষ্ট্ৰাকচাৰ ডেভেলপ কৰিলোঁ আপোনাক আৰু কিছুমান কথা ক'ব লাগে যে ছাৰৰ দৰে এনেকুৱা বহুত দূৰৰ কথা ভাবিব পৰা মানুহ থাকিলে আমি আৰু বহুত ওপৰলৈ উঠিব পাৰিলোঁ এতিয়া তাৰ অলপমান দুখৰ কথা কওঁ মই এতিয়া তেতিয়া ছাৰে মোক তেতিয়া কৈছিল যে কটন কলেজ যদি ইউনিভাৰ্চিটি হ'লহেঁতেন তেতিয়া কৈছে যে DSTৰ এই প্ৰজেক্টটোত IIT মাদ্ৰাজে ষ্টাৰ্টআপ আৰম্ভ কৰিছিল 1995 নে 96ত যিটো আমি এতিয়া দেখিছোঁ আমাৰ মোদী গভৰ্ণমেণ্টে ষ্টাৰ্টআপ কৰিছিল তেতিয়াই কৰিছিল ছাৰৰ মূৰত সেইটো আছিল যে ইউনিভাৰ্চিটি যদি হ'লহেঁতেন বিকজ এ জেনেৰেল কলেজ কেনট হেভ ডেট ষ্টাৰ্টআপ সেইটো হয় চক তেতিয়াই ছাৰে ভাবিছিল এইবিলাক কথা তাৰপিছত যে মই কৈছোঁ যে এই আমি ইণ্ডিপেণ্ডেঞ্চ পোৱাৰ কাৰণে তাৰ ইনফ্ৰাষ্ট্ৰাকচাৰ EDCত কোনেও লিখা নাই EDCৰ কথা অৰূপ মিশ্ৰ তোমালোকো আহিছিলা ইয়াতে EDCত আমাৰ ইনফ্ৰাষ্ট্ৰাকচাৰ ইমান ভাল কৰিলোঁ বিকজ এই পাৰ্টিকুলাৰ প্ৰজেক্ট ইজ ফৰ 5 years কিন্তু তেওঁলোকে কৈ থাকে মানে DSTৰ পৰা কয় যে তোমালোকে চেল্ফ ছাষ্টেইন কৰা আমি তাৰ পৰা আমি ইয়াতে মাছ কমিউনিকেশ্যন চেণ্টাৰ আৰম্ভ কৰিছোঁ 2005ত আৰু তাৰ পৰা এইটো ইট বিকাম ছ' ইম্পৰ্টেণ্ট যে কথাবিলাক ভাবিব নাই ছাৰে দিছে দিহা পৰামৰ্শ যে আমাৰ মাছ কমিউনিকেশ্যনৰ পৰা পাছ কৰা ল'ৰাই ইমান এমপ্লয়েবিলিটি হৈছিল আমাৰ হাণ্ড্ৰেডছ অফ পিপল গট এমপ্লয়মেণ্ট কিহৰ কাৰণে বিকজ EDCত তাৰ ছাপ্লিমেণ্ট কৰিবৰ কাৰণে আমি কিছুমান ট্ৰেইনিং কোৰ্চ কৰিছিলোঁ যিট ইজ ৰিলেটেড টু মাছ কমিউনিকেশ্যন গতিকে এটাই এইটোক ছাপৰ্ট কৰি আছিল আৰু যেতিয়ালৈকে কটন কলেজৰ এক্সিষ্টেঞ্চ আছিল তেতিয়ালৈকে EDC আছিল আৰু 2017ত যেতিয়া কটন ইউনিভাৰ্চিটি হ'ল মানে মাৰ্জ হৈ গ'ল লগে লগে ইউনিভাৰ্চিটি অথৰিটিয়ে যিটো আমাৰ মাছ কমিউনিকেশ্যন ইজ এ পাৰ্ট অফ EDC তেওঁলোকে আমাৰ বুলি কৈছোঁ মই ইনভলভ হৈ আছোঁ আমাৰ বুলি নকওঁ বাৰু EDCৰ যিখিনি ইনফ্ৰাষ্ট্ৰাকচাৰ আছিল উইদাউট স্পেণ্ডিং এনি মানি দে হেভ ষ্টাৰ্টেড ডেট ডিপাৰ্টমেণ্ট আৰু লগে লগে EDCৰ মৃত্যু হ'ল সেই সময়ত আমি ভাবিব লাগিছিল ছাৰ তেতিয়া এক্টিভ নহয় নহ'লে ছাৰে আহি কিজানি হুলস্থুল কৰিলে হয় তোমালোকে এই ষ্টাৰ্টআপ আৰম্ভ নকৰা কিয় ইনষ্টেড অফ কিলিং দিছ EDC এইটো হৈছে এতিয়া মই কথা কৈছোঁ যে ছাৰে যে কটন কলেজৰ প্ৰতি যিটো অৰিহণা ইন অল ৰেচপেক্ট বাকীবিলাকতো আপোনালোকে কৈছে ইনষ্টিটিউশ্যন এনেকুৱা কৰিব পাৰে নেকি মই এটা আজি বহি ইয়াতে মই কথাটো ভাবিছোঁ লগে লগে মই অৱশ্যে এলামনি এছ'চিয়েশ্যন জেনেৰেল ছেক্ৰেটাৰীক মাজতে ফোন কৰি আহিছোঁ মোৰ হঠাৎ মনত পৰিছে যে আমাৰ ইয়াত কটন কলেজৰ এই যে উন্নতিত ছাৰৰ যিটো ভিতৰত আছে সেইটো মানে মনত ৰখাৰ ব্যৱস্থা কৰিব পাৰে আপোনালোকে ভাবি চাব কি কথা আমাৰ ইয়াত যে আৱক্ষ মূৰ্তিবিলাক আছে কটন ইউনিভাৰ্চিটি এতিয়া কটন কলেজ কাৰ আছে হেনৰি কটন মাণিক চন্দ্ৰ বৰুৱা সুদমাৰ্চন আছে প্ৰত্যেকটো কটন কলেজৰ লগত ৰিলেটেড কোনোবা এজনে সপোন দেখিছিল কোনোবা এজন আৰম্ভ হৈছিল কোনোবা এজন প্ৰিন্সিপাল হৈছিল ছাৰৰ এটা আৱক্ষ মূৰ্তি এটা কৰিব নোৱাৰোঁ নেকি আমি যদি আৱক্ষ মূৰ্তিত ক'ত কৰিব পাৰে মই এটা কথা কোৱা নাই যিহেতু মই কৈ আছোঁ যে মোৰ যিটো প্ৰবন্ধ আছে তাত লিখিছোঁৱে ছাৰৰ ইমানখিনি কথা ভাবিছিল যেতিয়া চেণ্টিনেৰী হৈছিল 100 বছৰ ধৰি কটন কলেজত এলামনি এছ'চিয়েশ্যন নাছিল ছাৰে এইটো উদ্যম লৈছিল কটন কলেজ এলামনি এছ'চিয়েশ্যনৰ প্ৰথম প্ৰেচিডেণ্ট ছাৰ আছিল কটন কলেজৰ এলামনিৰ প্ৰেচিডেণ্ট হিচাপে ছাৰে মানে মই কিছুমানে নাজানিব পাৰে কটন কলেজ চেণ্টিনেৰী চেলিব্ৰেশ্যনৰ মই জেনেৰেল ছেক্ৰেটাৰী আছিলোঁ ছাৰে যিটো হেল্প কৰিছিল যেনে ছাৰৰ কাৰণে প্ৰফেচাৰ যশপাল আহিছিল ছাৰে আমাক দেখুৱাইছে অমৰ্ত্য সেনকো মাতিব লাগে তেওঁ চিঠি লিখিছিল আমি এইবিলাক কথা ভাবিবই নোৱাৰোঁ ছাৰে এইবিলাক কাম কৰি আছিল তো এইটো কথা আপোনালোকে ভাবিব পাৰে নেকি চাবচোন কাৰণ ইয়াতে ইউনিভাৰ্চিটি অথৰিটি আছে ময়ো অকণমান এলামনি এছ'চিয়েশ্যনৰ লগত ৰিলেটেড আৰু আছাম ছায়েন্স ছ'চাইটি আছে আৱক্ষ মূৰ্তি এটা যদি আমাৰ এলামনি এছ'চিয়েশ্যনৰ আশে পাশে এটা ছাৰ এটা জ্বলন্ত এটা উদাহৰণ হৈ থাকিব কটন কলেজৰ লগত কটন ইউনিভাৰ্চিটিৰ লগত সদায় আমি মনত ৰাখিব পাৰিম কথাবিলাক এইখিনি ক'লোঁ মোৰ ক'বৰ ইচ্ছা আছিল মোক ইয়াতে মই ছাৰৰ ঘৰৰ লগতো মোৰ বিশেষ ধৰণৰ সম্বন্ধ মাজনী আচলতে নামটো নাজানোৱে দেই মাজনীৰ কি নাম আছিল কৈছিল যে আপুনি এবাৰ অলপমান কথা ক'ব লাগে মই নিজেও কোৱা নাছিলোঁ বোলে কম দিয়া কাৰণ এইটো মই যিটো ফালৰ পৰা কথা কৈছিলোঁ সেইখিনি বাকীবিলাকতকৈ অকণমান বেলেগ আৰু মই নোকোৱা কথা মই আজি কোৱা নাই মোৰ প্ৰবন্ধটোত বাকীখিনি লিখিছোঁ আৰু সেইবিলাক এই যিখিনি কৈছোঁ সেইখিনি তাত লিখা নাই সেইখিনি কৈছোঁ নমস্কাৰ আপোনালোকক অলপ সময় ল'লোঁ আপোনালোকে ভাবি চাবচোন কথাটো গোটেইকেইজন ইয়াতে ষ্টেক হোল্ডাৰ আছে আমাৰ ভাইচ চেঞ্চেলৰ আছে বা অৰূপ আছে আৰু এলামনি এছ'চিয়েশ্যনো মই আছোঁৱেই লগতে আপোনালোকে ভাবি চাব ধন্যবাদ
Thank you so much, sir. With this, we would like to conclude today's memorial lecture. I would request the General Secretary of Assam Science Society, Shri Mrinal Kumar Hazarika, to deliver the formal vote of thanks.
সন্মানীয় অসম বিজ্ঞান সমিতিৰ সভাপতি শ্ৰদ্ধাৰ অৰূপ মিশ্ৰ ছাৰ আমি আজি ইয়াত বক্তৃতা প্ৰদান কৰিবৰ কাৰণে মাতি অনা বিশ্ববিশ্ৰুত বিজ্ঞানী সৌমক ৰায়চৌধুৰী ছাৰ কটন বিশ্ববিদ্যালয়ৰ ভাইচ চেঞ্চেলৰ ডক্টৰ ৰমেশ ডেকা ছাৰ আৰু সন্মানীয়সকল পাইখিনি গ'লগৈ মই দীঘলীয়া নকৰোঁ প্ৰথমেই মই স্পেচিয়েল থেংকছ দিছোঁ শ্ৰদ্ধাৰ ৰায়চৌধুৰী ছাৰক ছাৰে ইমান বিজি লাইফত বিজি শিডিউলত আজি আমাৰ মাজত আহি সুন্দৰ লেকচাৰ এটা দিলে মই বহুজনৰ পৰা মই পাইছোঁ ফিডবেক যে ছাৰৰ লেকচাৰটো ইয়াত থকা পাই সকলোৰে বুদ্ধগম্য হৈছে মই ছাৰক আকৌ এবাৰ আহ্বান জনাইছোঁ সময় পালে আকৌ এবাৰ অসমলৈ আহক মই এই অনুষ্ঠানটো সফল কাম নহ'লহেঁতেন যদি কটন বিশ্ববিদ্যালয়ৰ উপাচাৰ্য ডক্টৰ ৰমেশ ডেকা ছাৰ কটন বিশ্ববিদ্যালয়ৰ সমগ্ৰ পৰিয়ালবৰ্গই আমাক ছাপোৰ্ট বা সমৰ্থন নিদিয়াহেঁতেন মই কটন বিশ্ববিদ্যালয়ৰ সমগ্ৰ পৰিয়াললৈ অসম বিজ্ঞান সমিতিৰ হৈ শলাগ লৈছোঁ অলকা বাইদেউক অলকা মেমক লগতে দিবাকৰ গোস্বামী অনিমিতা গোস্বামী মাজনী ৰাজ আছে বহি পেলাই আমাৰ জোঁৱাই সেই সকলোকে তেওঁলোকৰ সহায় নোপোৱাহেঁতেন বোধহয় আমি এনেকুৱা এটা অনুষ্ঠান অসম বিজ্ঞান সমিতিয়ে ইমান আটোমটোকাৰীকৈ ইমান সৌষ্ঠৱপূৰ্ণভাৱে অনুষ্ঠিত কৰিব পৰা নগ'লহেঁতেন মোৰ সন্মুখত আজি বহুকেইজনেই সন্মানীয় শিক্ষাগুৰু তথা অসম বিজ্ঞান সমিতিৰ মাৰ্গদৰ্শক প্ৰাক্তন সভাপতি প্ৰাক্তন প্ৰধান সচিব বহি আছে তেখেতসকলৰ আমি প্ৰায় ঘৰে গৈ নিমন্ত্ৰণ দিছিলোঁ আৰু তেখেতসকল আহি সময়মতে আহি অনুষ্ঠানটো সময়মতে আৰম্ভণি কৰিব পৰাৰ যিটো সুবিধা কৰি দিলে ছাৰসকলক আমি শ্ৰদ্ধা জনাইছোঁ শ্ৰদ্ধা জনাবলৈ পাই মই সুখী হৈছোঁ যে অসম বিজ্ঞান সমিতিৰে প্ৰাক্তন প্ৰধান সচিব বৰ্তমানৰ ষ্টেকৰ ডাইৰেক্টৰ ডক্টৰ জয়দীপ বৰুৱা তেখেতো আমাৰ মাজত আছে তেখেতেও ষ্টেকৰ পৰিয়ালৰ বৰ্গৰ হৈ আছে প্লেনেটৰী আমাৰ বাবুল বৰাও আহিছিল অলপ আগতে তেখেত গৈছেগৈ তেখেতকো আমি আমাৰ ফালৰ পৰা শলাগ লৈছোঁ শলাগ নল'লে বেয়া হ'ব অপৰাধে ধৰিব বা আমি অসম্পূৰ্ণ হ'ব অসমৰ বিভিন্ন প্ৰান্তৰ পৰা শাখাসমূহৰ সদস্যসকলে পকেটৰ ধন ভাঙি আজি এই অনুষ্ঠানটোলৈ আহিছে তেওঁলোকলৈ মই শ্ৰদ্ধা সহকাৰে শলাগ লৈছোঁ এইবাবে লৈছোঁ যে তেওঁলোকৰ নিজা ডিউটি বাদ দিও আজি এই অনুষ্ঠানটো সফল কাম হোৱাত তেওঁলোকৰ সহযোগিতা সদায় অসম বিজ্ঞান সমিতিয়ে কামনা কৰে আৰু আজি তেওঁলোকে সেইটো কৰি দেখুৱালে আমি ইয়াত উপস্থিত থকা ট্ৰিবিউনকে আদি কৰি প্ৰিণ্ট মিডিয়া ইলেক্ট্ৰনিক মিডিয়াৰ বিভিন্নসকল আছে সেই সকললৈ আমাৰ শ্ৰদ্ধা ভৰা শলাগ লৈছোঁ তেখেতসকলে শলাগ নোলোৱা তেখেতসকলে বোধহয় নাহাহেঁতেন অনুষ্ঠানটোৰ আগত আৰু অনুষ্ঠানটোৰ পাছত অহাকালিলৈ তেওঁলোকে যাতে এই অনুষ্ঠানটোৰ ক্ৰীমখিনি অনুষ্ঠানটোৰ ৰাইজে বুজিব পৰাকৈ কাকত প্ৰিণ্ট মিডিয়াত আৰু ইলেক্ট্ৰনিক মিডিয়াত প্ৰচাৰৰ ব্যৱস্থা গ্ৰহণ কৰে তাৰ বাবে তেওঁলোকলৈ মোৰ ব্যক্তিগত নহয় অসম বিজ্ঞান সমিতিৰ বৃহৎ পৰিয়ালটোৰ হৈ পেলাই অনুৰোধ শেষত যিসকল ইয়াত ৰাতিপুৱাৰ পৰা লাগি আছিল মোৰ সহকৰ্মী বন্ধুবৰ্গৰ জইণ্ট ছেক্ৰেটাৰী ষ্টেণ্ড ছেক্ৰেটাৰীকে আদি কৰি ৱৰ্কিং প্ৰেচিডেণ্টো আছে তেখেতসকললৈ মোৰ শ্ৰদ্ধা ভৰা সেৱা জনাইছোঁ লগতে কৈ দিছোঁ মোৰ সামৰণিৰ বক্তব্যত অসম ভাৰত তথা গোটেই নৰ্থ ইষ্টক বিজ্ঞানৰ প্ৰচাৰ প্ৰসাৰ বিকাশৰ বাবে বিভিন্ন অনুষ্ঠান গঢ়ি নিজেই অনুষ্ঠান এটা হোৱা অনিল গোস্বামী ছাৰৰ এই অনুষ্ঠানটো আমাৰ প্ৰেচিডেণ্ট ছাৰ ইতিমধ্যেই কৈছে আমি ভৱিষ্যত দিনতো অসমৰ বিভিন্ন স্থানত কটন বিশ্ববিদ্যালয়ৰ বাদ দি আমি অসমৰ বিভিন্ন স্থানত পতাৰ ব্যৱস্থা কৰিম আশা কৰোঁ আপোনালোকৰ সবল সহযোগিতা আমি সহযোদ্ধাসকলৰ পৰা আহ্বান কৰি মোৰ শলাগৰ অনুষ্ঠানটো সামৰিছোঁ ধন্যবাদ
Thank you, Shri Hazarika. With this, I announce the conclusion of the first Professor Anil Kumar Goswami Memorial Lecture. I thank each one of you for your presence today. Thank you.